Hello, welcome. So I'm Kelsey, and this talk is kind of has a weird title: Kelsey, Kubernetes, and GitOps. Um, I think you would think those three things go together, given my status in the Kubernetes community. But if you really want to understand Kelsey, you kind of have to understand the whole person. We like to label ourselves technologist, and just like many others, I've used many labels over my career. But the first label I've ever had, um, like many people, I worked in fast food, specifically McDonald's, where you get the purple hat and the shirt to match. You come home smelling like French fries and whatever they fried it in. And a lot of my work ethic, a lot of my maturity, this nature of being a professional started for me around the age of 15. And there's a long trajectory between those humble beginnings to the person you speak in front of you today, or commit to your open source or your favorite open source project. And a lot of us try to figure out what's the success behind it. And I don't have a lot of answers, but I know I've been on this marathon for a little while now. And there's a big checkpoint in my career. I remember getting my first like real corporate job, the one where they make you wear slacks Monday, Tuesday, Wednesday, Thursday. And then on Friday, if everything turned out okay, you'll get to wear jeans. And it was a financial services job. And I remember I was a system administrator, just learning things like Python and all of this automation stuff. And it's really when I leaned into ops big time. This is when outages and production really mattered a ton. And I remember one of our outages, we're sitting in one of those war rooms. And for y'all watching this that have never been in a war room, think about a very small office space with a bunch of chairs lined around, and everyone's on their laptop, sometimes pretending that they're actually working on a problem, even though they don't know what's going on. And I remember we're taking longer than normal to resolve the issue. And the company I work with, they process credit cards, the things you keep in your wallet. And they also process the EBT cards. So for people that are getting assistance from the government, they have these plastic cards. And the reason why they give them those plastic cards instead of this different form of money is there's a lot of pride and dignity and convenience being able to swipe and pay for your groceries. So during this outage, guess what? Those cards don't work. And I remember the CTO walking into the room, and I'm not sure if everybody was taking everything super serious, and maybe I wasn't as focused as I should have been. And I remember him walking into the room, and he told us really impactful story. And he said, while we're trying to figure this issue out, we have a customer that's been going up and down the groceries aisle, basket full of groceries. And maybe this person has their kids with them. And they're in this checkout line, and they're about to go next. Now it's their turn. And all they have is this EBT card. And they go to swipe it to pay for their groceries that have already been rung up, neatly placed in the bags. And the EBT card doesn't work. And here we are sitting around this room believing that we have all the time in the world to resolve the issue. It's just another outage. We'll restart some servers, and eventually the system will come back up. And he explained to us that unlike a lot of our other customers, this person doesn't have another credit card to go to or another form of payment. If that card continues to decline, then they're going to be stuck, or the most embarrassing thing, having to put all of those groceries back and then leave home or leave the grocery store empty-handed. At that particular checkpoint in my career, I kind of understood that there's a lot more than just writing scripts and throwing them at servers and hoping they work. We need better tools. We have to take the situation a little bit more serious, start to understand things like SLA and building resilient systems, and also figuring out what the hell's going on. Why do so many of us fly blind in production, and in some cases laugh and joke about it? The systems that I grew up on, they were just like these black boxes that we owned. Even though we could log into them, most of us didn't even know what was running or how it ran. We just knew if you restarted enough, it would eventually work. We always think we have all the time in the world. And I remember a lot of people telling me, success is measured in time. I remember getting an award like top 40 under 40. And I always thought to myself, it's like, why is there a time limit on this kind of thing, right? Why is there not more opportunities for success that have nothing to do with your time? The truth is there is no time limit. So what I'm going to do right now is I'm going to share my screen. And this is a very interesting number. If you're using GitHub, you may be fascinated with the number of GitHub stars. Apparently, if you get over like 100 GitHub stars, you can probably raise an A round in Silicon Valley. So those numbers do have meaning. But this number on the screen, 1 hour, 59 minutes, and 40 seconds. If you pay attention to the sporting world, this is the current world record for the fastest human being to run a marathon. Most people can't run a single mile in an hour and 59 minutes. But Eliud Kipchoge, he did it. And we tend to put the person who crosses the finish line first in the foreground. Look at this picture. Notice behind him, all the other runners are cheering. That seems a bit odd. It's supposed to be a marathon. That's like a race. Winner take all. There's only one first place finish. But the people behind him, if you watch this, if you watch what happened, the people behind him are also world-class marathon runners. In this picture, you see 8 people in a peloton formation. You can see birds fly like this as well. The whole goal is to protect the runner from any wind resistance and help him keep pace. There's about 30 other world-class runners in this formation. All of them are taking turns. So maybe you run a few miles and maybe the top 2 guys switch out and the other 2 join in. Now, any of the 30 who've been training for months to help them break this world record of a person running a marathon in less than 2 hours, something we didn't think was humanly possible, they all decided that it was his goal and they would be the supporting cast. And they stayed in this formation to perfection, switching in and out without slowing him down. Now, if you ask vendors, how does this work? Maybe we don't talk about the human beings and their upbringing. Maybe we don't talk about all of the practice. Depending on who you ask, maybe if you ask Nike, they would say, it's got to be the shoes. Honestly, I've never met anyone walking around saying that they wanted some Eliud Kipchoge's. They look great for running marathons, but I don't know if you're going to be rocking these to any sporting event. So the truth is, it's the humans that should be front and center. Today, we're going to be talking about Kubernetes and GitOps, and the thing that kind of depresses me a little is that we tend to put all of these tools before the humans that use them. When you think about Git, it's one of the world's best collaboration tools for writing software, and GitHub is where we all meet and collaborate. But it's the people that make all of this work. And when people think about Kubernetes, they want to hyper-index and hyper-optimize on containers versus this other thing. And you could do that. You can click on all the Hacker News links and have about 10,000 tabs in your web browser. But if you focus on the technology, I don't think you'll ever get it. What we've been doing with all of these platforms is serializing the way we work. There's been a lot of ideas over the last 20 years, and a lot of them have been serialized in Kubernetes. That's the gist of it. I know people want it to be more complicated than that. There should be a series of best practices. Hell, I even wrote a book about it. But the truth is, there's just practice. And as we learn, we'll contribute to those things. If you have a clear goal, if you know what you're trying to do, maybe you know where the finish line is, you can actually bring in all of these people and all of these tools, and they should be aiding you to go faster than you can by yourself. Now, Eliud Kipchoge, he is a world-class marathon runner. He's never ran the marathon in less than 2 hours. He's gotten close, but he's never been able to do it on his own. And sometimes because he's the only one in front and there's no one there to push him. But with this setup, it changed the game. And if you do it right and you keep these kind of North Stars clear, then I think it makes it much easier to understand how all the technology comes together and the people around it. You can wrap that around you and then use it to push you forward. That's the way you got to think about this. If you want to understand GitOps, you got to understand the why. Why are you using it? What's important about it? What's the Peloton formation you're trying to build around you? And is it designed to help you go faster? Or are you just doing stuff because people said it on Twitter? So now we're going to jump into kind of this live demo about how all of this works. So I'm going to switch over to my screen now, but I want you to keep that thing in mind. We should be using these tools to augment what we're doing, not become the whole thing that we're doing. So one thing we have to think about is, what is our actual goal? Most people write software to put it in the hands of their customers. So in this case, we're going to have a very simple app, because what I want you to do is focus on the actual workflow. That's what this whole GitOps thing is about. What type of application can you deploy? I don't know. What kind of applications can you write? So you see I'm rocking that new dark theme. Maybe this is going to be the new trend. And I just have a simple app. It's called Hello Universe. And as a developer, if you put your developer hat on, you have some very specific goals. Your goal is to write code that hopefully works, and then deploy it to the proper environments, and then you should be able to hit an endpoint and get some results. That's the goal. I'm going to show you what that goal looks like when in practice. So basically, I'm here on my command line, and if I run curl https, and it's called Hello Universe, and then I just have it running on my hightowerlabs.com domain. And there it is, it works. And currently I have version 1 running. So now what is all this GitOps hype about? Why is it going to change the way you think about things and work? The honest truth, it shouldn't. If you think about the way you write code today, if you're a developer, there's a big chance that if you're watching this talk that you're already using Git. Think about it. When you write code, you tend to make a few commits and then you push it up. You can run that binary locally if you really wanted to. I can do something like Hello Universe. I have this binary that's on my machine. I can run it locally. And if I were to go to another tab and call curl on localhost, the thing you expect to happen should happen. I could hit this on port 8080, and there we go. That's pretty straightforward. And then you push your code to some repository. But here's the thing. If you really want to know how this works, I think one of the best examples that I've seen online is probably to the people who coined the term, Weaveworks. They coined GitOps. And the whole goal behind GitOps is that, imagine if we were to able to use the same development workflow for managing infrastructure. But here's a twist. We've been doing this for a super long time. A lot of people will look back to like Puppet and Chef and Ansible, and we wrote a lot of code back then. And yeah, a lot of us checked into version control. So what's new about this? This looks like the same thing we've been doing, and someone just came up with a better name for it. That's probably true. And they raised a lot of cash behind it. But the ideas are solid. Why are they solid? Well, there's a twist here. Given Kubernetes and the way it works, we now can start to treat infrastructure as data. And a lot of people say, nope, I thought it was infrastructure as code. Yeah, you can write a lot of code, but code has some other issues to it. One, you need something that understands that programming language in order to write that code, parse that code, validate that code. And those tools exist, don't get me wrong. But the idea that if we can write code or config as data, maybe we can simplify this. I know what you're thinking. Oh, more YAML. Look, YAML ain't that bad. Stop complaining. It's readable. You can modify it, and we can run things like static analysis without having a compiler or something that can parse that language. An overview, this is what it looks like. I know people get this super complicated. I know a lot of people will talk about CI/CD and pipelines and deploying 2 trillion times a day, even though they don't have a reason to deploy 2 trillion times a day. It's something we brag about at conferences. Don't worry, it isn't real. The truth is, it's all about the workflow. How you encapsulate that workflow, well, that's going to be up to you. Look at this diagram. As a developer, on the left side, you write code, it goes into a version control system, and then ideally you're going to produce an artifact. So here's where this Kubernetes connection comes into play. Kubernetes requires a container as the price of admission. Oh, I know what you're saying. Oh my God, I got to build a container. This is the hardest thing in the world. Oh, it's going to take me 7,000 years to learn how to build a container. And I ask people like, wow, have you even tried? Like, seriously, have you tried to build a container before you start freaking out? Think about what's required, right? If you know how to build your app locally, right? Like these are the same kind of commands I would put in the build script. Then in my case, I keep things super simple. I build my app the same way I normally do. And then based on the results here, this hello universe binary, I simply copy it from my build step and then package it. We're really talking about glorified tarballs, but they're really powerful. But they are very similar to using things like Ruby gems or a war file if you come from the Java world. You got to package software in something. Why not pick something that's super universal? That's the selling point. If you don't like Docker files, there are other tools that can build container images. Get over it. Once you do, then the world kind of opens up to this other thing that we're talking about. In order for this GitOps things to work the way we're talking about it with declarative infrastructure, we don't want to be dealing with the differences between Node.js, Python, and Go. We want to have a normal, consistent object or artifact to deal with. Let's go back to the diagram really quickly. Notice this container registry component. That's the key to normalizing your workflow across all your applications. So what's the contract between you and the developer? Well, as the developer, your job is to write code that works. Ideally, it's secure as well. And then if you do that, we can automate the process of building those Docker files. So it's on you to put a description of how to build your app, right? And then when it's done, you can actually create that entry point so we know how to run it. So how do we automate this? Well, GitHub has a really nice feature. So in GitHub, you can actually do something pretty neat. You can set up some actions, basically. So when I push to this repository or tag a branch in this repository, it'll kick off a set of actions. And they have all of these nice little blueprints that say, hey, whenever code is checked in here, push to some repository. Before my talk, I was producing a few versions. I have a V1 tag and a V2 tag. And with these releases, just by doing the normal Git operations that I tend to do when I'm writing code, well, I can rely on GitHub Actions to take over that commit, and then it will go through and actually build my image for me and push it to a repository. Does all of this in the background every time I commit or tag something. And then once that's ready, the important part here is you want to push it to a central repository. If you haven't been paying attention, GitHub also has a new container repository. So you can manage packages for all your repositories. Look here, this is a Hello Universe Docker repository. Now, if you're new to this and you're not quite sure how that all works, just know that each of those tags produces one of these container images that I can either pull locally on my laptop, something like Kubernetes, or some serverless platform that supports containers. Now that we have a repository, let's pop back over to that diagram. Again, I don't think this has to be as complex as a lot of people make it, at least not the fundamentals. So now we have this part of the loop established. Checking in our code and making container images. Got it? So at this point, we're now ready to start releasing our application to something like Kubernetes. Now, how do you go about that? Well, you can do simple ops. And what ops looks like is, in this world, of the declarative world, is ops is about writing YAML files. Yay! One time for the YAML files. You'll learn to love YAML, I promise you. And if you have like VS Code and any of those robust editors, it will help you write a lot more YAML. So don't worry, YAML is your friend. What does that YAML stuff look like? I'm just going to show you one. Here's a deployment file. Really, the goal here is you to articulate what you want the system to do. I want to deploy this version of my application. I want this much memory and CPU. You get the idea. But ideally, you can have tools that help you generate these configs. They're very explicit. But the whole point here is that they're declarative. We're not writing any scripts. We're not using any custom languages or any custom tools. We're just crafting some data. The nice thing about this data is that we can push it to any Kubernetes cluster that we want. And the goal is between the deployment object and the service that allows me to attach this to a load balancer and the horizontal scaling config, I have the three components that I need for dealing with my infrastructure. So how does that work? Well, there's a bunch of things you can do here. Let's go back to the diagram. In this diagram, notice one thing that I like. This idea of splitting out the config repo from the source code repo. And a lot of people are like, oh no, you want to keep everything together. I don't think you want to do that. When you get to day 2 and day 3, there's going to be situations where all you want to do is modify the config and then push it. In those cases, you may not want to have a very complex build process that has to know the difference between a config change or the app itself. And then it gets really tricky when you start to deal with multiple environments. That one set of configs may not work well across multiple environments, especially over time. So if I were you, I would consider following this pattern, this blueprint. Keep your config repo separate. So what does that look like in the GitHub world? Well, you probably know what this looks like. If I click over here to my GitHub tab, I just have another repository where I'm storing all of my configs. And here I can have my same Git flow. I can do pull requests, I can review them, and all of my configs are just sitting here underneath this directory called Kubernetes. I can have other deployment targets. Maybe you're using a serverless platform like Cloud Run. And in that case, you may have another directory of declarative configs that you put there. But the goal is these are just all data artifacts that can be consumed by some other system that can actually take your declarative thing and make it work. Now let's pop back over to that diagram. And one thing I want you to pay attention to is you have two choices here. You can have something push these configs into your clusters, but I want you to think about that for a second. Push versus pull is a debate that goes back a long time. Not sure it's settled. But the idea here is that when those configs are ready, that's when you want them to go to your target. If you have lots of clusters, one model may work better than the other. One thing I like to do is give myself the flexibility to have different Kubernetes clusters have different versions of the config, even at the same time. Let's see what that looks like in practice really quickly. So I have a couple of live clusters running in my infrastructure. I basically have something in US West 1, US East 4, and I have another one in US West 1 in the B zone. Now, what I'm going to do is I'm going to treat this second cluster in US West as my canary cluster. Now, this is where things get a little interesting. I'm going to go with the pull model. I'm using a tool called Config Sync, and there's other great tools out there, some made by Weaveworks and many others. The choice is up to you. They all have different feature sets. Pick something that works. But the fundamentals are roughly the same. We want these clusters to link to our configuration repository. This is the core premise to what we're doing. We want these artifacts to work. So here's the other thing we want to do. I want to leverage multiple branches. That way, maybe I want 1.0 deployed to all of the clusters. And when 2.0 is ready, maybe I tell just one cluster that it should be running the 2.0 version of my configs. And we'll see what that looks like. All right, so let's see where we are. At this point, we have everything set in terms of our config. I have a line tool called Nomos, which is part of the command line tool that allows me to interact with the config sync repositories. So what I'm going to do now is going to run the Nomos command, and I'm just going to get the status of my current deployments. So if I run the status command, it's going to connect to my clusters and tell me the current status of the repositories that it's been syncing to. While that's running, what I'm going to do now is run that curl command again, and you'll notice that we're hitting our universal URL. And that universal URL is pointed at all of my Kubernetes clusters. I have a load balancer sitting here, and that load balancer is pointing to 3 different clusters. Hello Universe is pointing to all of those zones. Here we go, down here. So with that, if I hit the global URL, I'll be routed to the cluster that's nearest to me. So if I run this command here, we should be getting the 1.0 version. And if we look at our syncing, we'll see that all three clusters, US West 1, A, and East, all of them are syncing to the 1.0 branch of my Hello World universe config. And they're all in sync. And I'm getting the right version. Everything's working nicely. So now I want to make that change. Well, of course, you update your code and you go back to the flow that you're used to, checking your code. And then what will happen is a build process will kick off, drop something in your package repository, give you a new tag that's eligible for deployment, and then all you have to do is make a change in the config repository. Now, there's ways to automate this, but I just want to show you how it works underneath the covers. Your goal is on that separate branch where those configs live. Well, those configs, I'm going to show you the diff really quickly. If you look at those configs on the second branch, there's only one small change. And the change here is just to that deployment artifact. If you look here, I just went from 1.0 to 2.0, and it's sitting in this branch ready to be released. So how do we release it to the cluster? Well, there's one thing we got to do here. When I set up these clusters to pull from that repository, I did a little bit of work ahead of time. I have this config management directory. And if you look at them, they're currently all the same. But let's look at the one that I've deemed our canary cluster. So what I've done is I have a separate load balancer that's sending traffic only to one of these clusters. And it's called Hello Universe Canary. If I click on that, you'll see I have its own IP address, its own set of domain names, and it's only pointed to one of my clusters, US West B. Now we'll hit that endpoint, and I'm going to show you the last step that you have to do as I wrap up this demo. So we'll do curl, and this time we'll throw canary into the front of this. So we'll say canary.hellouniverse, and we'll get the version. As expected, we're getting 1.0. Now I have those stages changed. I have the containers built. We only need to do one more thing here. We'll update the config management config just for that one cluster. So we'll say US West 1B, and we'll come over here and say, look, I want to sync instead of the branch 2.0, 1.0, we'll change it to 2.0. And then what we'll do here is we'll tell that cluster that it should reprioritize where it's pulling config. And the way we do that is we run a command. So I'm going to be talking to specifically that cluster in US West 1, and I'm going to tell it to grab that new config. We're reaching that last mile now. If I push this config up, what will happen, and we'll pop back over to the diagram. Once this config is in place, that Kubernetes cluster will go to that new branch of that config repo and then try to update the state of the world based on those configs. The nice thing about this workflow is that developers can keep checking in code and tagging releases, and then those will flow into the container registry. Only when the config repo is updated specifically for a specific environment will it go and pull the right container at the right time. So for most people, once you get this stuff set up, you end up working like you were normally working. Now you kind of have this GitOps workflow on both sides. You can start the diff, review changes, merge them in. So with that in place, one thing we're going to do now is going to run that nomos command one more time. And what should happen is I should see that second cluster or that canary cluster starting to sync. If I go over here and look at the cluster output, we'll look at our workloads, and we should see Kubernetes hard at work trying to replace some of those old versions of my app one by one, or how I direct it based on my controller that's doing the work inside of the cluster. Remember, everything's declarative on my side. I got a few more pods to go. We'll hit refresh here to see if everything is up to date. And we have one more that we're shutting down, but so far it looks like everything is green and we're ready to test. So let's see if this works. We'll go back to our command line and we'll hit that canary endpoint again. And we see it's on 2.0. And just to be sure that everything is working, we'll hit the global load balancer. And ideally, we're going to bounce around to various endpoints. But since I'm closest to this particular zone, I'm still getting 2.0. Now, there's many ways you can go about this. Maybe use GitHub Actions to validate those configs before you put them into a branch. And then maybe you automate the process of grabbing the latest container version from the container registry and updating the configs. So with that, I'm going to stop the presentation, and hopefully you have a better understanding of how GitOps works. There's a lot more you can do here. We just scratched the surface. A lot of people are looking at this as a very complex thing, but remember, you already know most of the workflows. You've probably already been working this way. It's just about combining these two things and understanding the little catch here is declarative infrastructure like this really requires something that can manage the full life cycle of your apps or your databases. And with that, I'd like to end the presentation. Thank you.
All right, so hi, welcome to my talk. I'm Eliza. I'm an artist and a programmer, as well as a researcher and an educator. And some of my past lives include a brief but illuminating stint in advertising, as well as a fascinating period I spent working as a journalist. I was there on the cusp of social media, so it was definitely interesting to witness the shift in how things were done in a newsroom. And I worked for quite a while in video too. I wore many hats in that industry, content creation, but definitely I enjoyed editing the most. And I mention these past lives because there's an interesting common thread that kind of weaves itself through there. And that's that each of these industries and the positions that I occupied kind of rely on people's emotional response, people's senses being triggered in some way. And while I'm not so into the commoditization of that, I have always been pretty interested in these topics of emotional response and why and how people feel and all that. And, you know, my time working as a brand strategist and as a journalist certainly allowed space for me to explore that, as did the time I spent editing videos. Each of these areas kind of represents their own opportunity to observe and inquire about what makes people respond. But it wasn't until I really got my hands dirty with code and CG, computer graphics in particular, that I was able to find the ideal conduit for me to explore sensory response, emotional triggers, in a way that felt right and integral for me. My work is very focused on experimentation, and that's as true for me as it is for others. Like, I want to experiment, make cool things, learn new things, and hopefully anyone who encounters my work, you know, gets drawn in, feels that pull to play around and work out what's in front of them, and how they feel called to interact with it. So that's kind of the overarching theme for me. As someone who is a self-taught programmer for the most part, definitely when it comes to, you know, CG, I've learned to really appreciate the science of math and, you know, all the funky things that we can do thanks to numbers. And any past math teacher of mine would probably spit their coffee out hearing me say that. But yeah, and I can go in so many different directions with this, but in particular right now, what I'm talking about is shaders, which are definitely up there for me when it comes to things I'm excited about and kind of forever obsessed with. Shaders make things look pretty, or I should say shaders make things look however you want them to look. And that's important because in my case, I want people to want to touch the 3D creations that I make. And so I use shaders to support that, but that's a lot of math. And, you know, on the topic of math, it's just so crazy to me to think that I can use like the rhythm of a sine wave to create patterns on a screen. So yeah. And just a quick shout out, because she's in the GIF with me, to Alethea, the lovely friend of mine with whom I often code shaders. Yeah, we get together and kind of record snippets of ourselves coding shaders, and it's a lot of fun. So yeah, I'm equally a big fan of collaboration and pair programming. Some other things that I enjoy using code for include sound. I use this tool called Orca, which was created by 100 Rabbits, and I love it because there's just very sparse kind of documentation. It kind of forces you to just play around and explore, which are two guiding principles in my work, I guess. It's probably become pretty clear at this point. but yeah, because we're not here for rules, at least I'm not, and not all play needs rules, right? And again, here, the same math that kind of governs shader coding also governs the frequencies that I use, in my sound exploration. So it all comes back to the sine wave, which just, it's the overlap, that common language to express something that's so vastly different, like colorful pixels dancing around on a screen, and an actual sound that you hear reverberating in your head. But these are just some of the interests, I think, of mine that complement and support the larger core of what I do, which is using real-time and mostly 3D graphics to explore interactivity and sensory response in the overlap between the digital and the physical world. So let's talk about the overlap for a second. I spend a lot of time playing around with merging the digital with the real. I'm really interested in kind of hijacking, or I guess repurposing, the tools that I use, that being code and the computer and, otherwise binary digital tools, to create things that kind of encourage a broadening of our conception of what here versus there might mean, as well as, what actually generates sensation in our bodies. We're so used to thinking of sensation through the conduit of physical touch, but things are not always so explicit. I'm very, very curious about how technology can be used to get us back in touch with ourselves, our bodies, our present kind of state. So often we hear about all the ways that technology disconnects us from each other and from ourselves. And so I became interested over the years in exploring the ways in which it might also be used to kind of do the opposite. In particular, I'm really into textures and playing around with the look and feel of things. So again, shaders come in handy here. But, making something that simultaneously generates both a feeling of like familiarity, but also alien, like it feels alien enough that we're provoked in some way. And so the idea is to confront those two feelings, those two sensations. And there's a certain charm too, I think, to creating something that evokes the natural world, even if it's just like really subtly, but doing that with such a clunky tool as like code and a computer, But yeah, this seems to be the key I've discovered, or at least one of them. So this is one of my earlier pieces. It's a jiggly eye. And it got a really great response when I first showed it. People didn't quite know what to make of it. Were not sure how they felt about it. And so, back to what I was saying, like I found a key, but the key to what? Well, to jarring people, essentially. Just enough that their head kind of like cocks to the side a bit, and maybe their senses tingle, in such a way that that they find themselves called back to presence, even if it's just for like 1 second. It's that second that destabilizes the psyche and kind of tickles our intuition and makes us want to, reach out and touch what we see. And yeah, so the digital hands in these images are projections of my own hands being tracked in real time by a sensor. You'll also probably have noticed a bit of a bubble theme throughout my work. I really like soft, squishy things. Touchability, if that's a word, is really important to me. There's also this quality to bubbles that seems to kind of induce immediate wonder in people. I remember being in California at Golden Gate Park last year, and there was this man who had set up shop on the grass making these huge, massive bubbles. And I mean like body size bubbles, like adult body size bubbles. And kids would come running up to them and try to catch them, and adults did too. And you just had all these people, young and old, kind of like running around on the grass with their hands in the air, trying to catch those bubbles. And everyone was laughing. It was such a moment of pure happiness. It was like just really cute and nice to see. And so bubbles, I mean, they kind of have this really irresistible pull to them. So yeah, that's the hope, basically. The hope is that people are enticed into reaching out and reaching into, or feeling drawn in, in a way. And maybe it's that feeling that they can't quite describe. Like they don't really know what it is that they're feeling, but they know that they're feeling something. I got that a lot with this demo too. This is to furry bubbles, and the different textures of fur, of hair, really threw people off. So I'd say that so far I'm not, totally failing in my endeavor. I've gotten a lot of fun feedback from people that my work made them feel weird, which to me is the highest compliment. And I've also gotten that same kind of feedback from people who have seen but not directly experienced having their hands projected into the parallel world, which is so great. I mean, to me, it means that I've really kind of accessed that ASMR space. And having a physics engine to mess around with definitely helps with that, because you can, take the rules of the natural world and just kind of mess with them, But on the topic of touch, some people actually don't, like being touched, and still want that proximity, that closeness to others. This is a project that I've been working on with two other artists, Ines Alpha and Marpy, who are two really awesome and mega talented humans. The project is called Supermorphia, and it basically kind of indirectly ponders this question in the most colorful way possible. We wanted to combine all of our aesthetics, maintain that same kind of, eerie but familiar vibe that shows up in Marpy's work as it does in mine, and create some unique 3D makeup, which is Ines's specialty. Her aesthetic is also pretty out of this world, like in the best way. So it was just a lot of fun to work on this all together. And we ended up designing something that basically allows us to draw the makeup right onto our faces, as well as on each other's faces without ever touching them. So that physical boundary is maintained. This is a bit of a departure from the face filters that social media has made us all so familiar with, I think, at this point, because here we're really selecting and applying the makeup kind of like however and wherever we want on our face. Here we're basically presented with this idea of sensation elicited from kind of implicit instead of explicit interaction. And here I'm talking about interaction, of course, between two physical bodies, because, of course, we're interacting with a computer. But there's also just this perception of how a certain type of makeup feels versus another when experienced through the screen, but also on my face. Like in our case, we chose 3 types of makeup. Let me go back the previous slide because I think it's clearer. We chose 3 types of makeup, each with their own kind of vibe, like stiff diamonds, jiggly bubbles, because of course, and sinuous kind of flowery vines. And there's something just really special about applying it yourself. It's been a really wild ride trying to get all of this to render in real time properly, but it's been really fun and we all learned a lot. And so, digital playgrounds, there are no rules and you get to work out what the experience is for yourself. And if you spend enough time playing with the makeup, you might, let me show you that video again, you might discover that you can connect to the other person with your makeup. And so, you're touching each other without touching, which elicits, its own host of sensations, and everyone is different. So the sensations are super personal and individual. Like here, you're going to see Ines and I connect to each other via the same kind of little tendril there, and then we can pull it apart, and it wants to touch. So that was a fun little detail we discovered. Another idea that's pretty front of mind for me these days is kind of just that notion of being in 2 places at once. Because you've got a kind of portal situation happening with this kind of technology, right? Where you're transposing yourself, or part of yourself at least, in real time into digital spaces that are kind of parallel to ours, worlds just beyond. So to me, XR as a concept really allows for that to exist and be explored, to be able to be where I am here now, but also be in that somewhere in that scene, touching something, which creates a sensation that I can feel in my body here now, right? Like that's what I'm talking about. Let me show you a clip from a show that I did in San Francisco last year. There we go. One of my favorite things to witness when I get, to see people play with my work is how quickly they kind of get wrapped up in the moment and forget that they're in a public space and that there are other people around. So it's nice to see that kind of like letting go. And you see it a lot in interactive pieces that play on mirroring movement back to you in a slightly off-kilter way. Adults kind of turn into kids again, and it's just so great. Like for a moment, they access this really inquisitive, kind of intuitive space of wonder. Yeah. So here's a little montage of people's hands from the show that you just saw a video of, to showcase the many approaches people have when confronted by something like, the furry bubbles you just saw. I get a kick out of this slide because it's always super fun to see how people engage with your work. And also, it just kind of drives home the point that everyone approaches things so differently and plays differently, and that's totally fine. And in fact, that's kind of the point. So, to feel out how you want to approach something foreign that appears alien, but also inviting. And there's just something about doing this outside of the confines of a headset that to me really adds to the experience. I truly appreciate sensors and computer vision technology for that, because here what's capturing people's hand movements is a leap motion sensor, which you can't really see, but I love using the sensor with projected artworks because suddenly there's this, like I said, there's this window into another world, and you can interact with that world, and not like as a shadow figure and an invisible force, but part of your body is in there. But it doesn't quite move the same. And so it might solicit some surprising feelings from you again. Like that's the goal, right? And yeah, I have a really great clip. I'd like to share an extended clip from the same show of one of the attendees kind of experiencing all of the feels. Like she goes through the gamut, and I think it just really illustrates what I'm trying to say properly. So yeah, she comes up, she's not sure, she's curious but confused, reticent a little bit, but still like intrigued. And then she kind of lets go. I just love all of her facial expressions. It's great. Yeah. So I've had the immense chance to play around with some of the looking glass technology as well, which gets me really excited because I was raised on Star Trek. So anyone who says hologram to me gets my attention pretty fast. And so this is me playing around with their 8K screens, which are pretty impressive, to say the least. And again, here using the leap motion to kind of reach into a parallel space and influence whatever I might find in there. Here it's kind of looking into a void, but we have a riff on my hairy bubbles. I made them extra thick for the occasion. It was a lot of fun, and it was as I was starting to play around with looking glass that I really started kind of toying with this notion that I kind of demo with this example. The idea of breaking the fourth wall, it kind of started creeping into my work slowly, just this idea that the camera lens in the 3D scene might also be like a window, right, in both directions, because why not? Like, why is it just us looking in? Isn't that how portals usually work anyways? Like, they go in both directions. So yeah, I just like the idea of that world also kind of being able to at least feel the border between our two worlds. So yeah, maybe it isn't just about us kind of reaching in only, but also of them kind of understanding that there's a reaching happening and that there might be something beyond that wall. This is kind of a smaller looking glass device, and yeah, here I'm just kind of, like I said, inserting my hands into this whole other space that contains these like bubbles that can't escape. And it's a simple enough idea, but it kind of planted a third question in my mind. What if we kind of flipped everything that I've been saying on its head, and instead of giant hands descending into a parallel world, giant bubbles kind of emerged from a parallel world and came and arrived and landed in ours. So in the case of EP7, which is a building structure here in Paris, in a part of Paris that doesn't really look very much like Paris, I adapted one of my projects where normally, like you saw, you'd be able to kind of reach in and touch the bubbles with your hands. And actually, just for fun, I'll show you a clip from Burning Man from last year where I was able to put my hands up on a huge surface, and it really worked out with the play on scale. It was pretty fun. So yeah, we basically set up a leap motion sensor on a tiki torch, and I found some really long cables and got everything working. And it was just a really special place to show art, and especially being that I chose to put the eyeball up on the pyramid and the nature of the gathering. Yeah, it made for some really funny conversations. I got a lot of hugs that night. But yeah, given the nature of the screens for the exhibit at EP7, I opted to kind of swap out human hands and use the building as the interactive element instead of humans. It felt like the perfect place to kind of try out that idea, right, of the other world arriving in ours and kind of implanting in ours. The facade was made up of screens that were organized in a pretty exceptional way, at least in my experience. So I found it really fun as an idea to kind of, allow the building to take center stage. I saw it almost as kind of like a labyrinth, where bubbles could kind of like, wander and bounce around and sneak past corners and come up against the street side of the screen as well. Or kind of, I guess, what appears to be like a window between our two worlds. And just kind of experiencing it from that vantage point. I just like the idea of it not being one-sided, I guess. And there's also, I guess, this theme of like bouncing off the walls that just became ever present over the last year in my work. And at one point, over the last couple of months, or I guess over the last year, I got kind of overwhelmed with everything that was happening around me, right, in the world. And it seemed like life had kind of turned into this weird, bad blockbuster. I don't know really what genre properly fits to describe the year that is currently winding down, but I was in it and feeling like, I don't know, I just wanted to like get out, but there's no exit. So I guess I kind of translated that into my work a little too. It wasn't super conscious at the time at all. But this facade, my work was shown just after the government in France kind of started to allow spaces to open up again this summer. So it felt very appropriate to show this work there. And I just found that the facade would really kind of highlight this all beautifully, like the fishbowl kind of feeling that I had experienced at certain points of the last year, but also, that of being out in the world again and of kind of like a foreign kind of alien entity arriving and kind of implanting in ours. It felt like, kind of the perfect spot to try it out. And so anyways, that's a bit of a tangent, but I really like the idea of art as architecture, perspective and depth, and those kinds of mind-bending opportunities kind of set the stage perfectly for that portal feeling. And I was talking about that before. I guess here, this would be an example of when a portal was one-sided, but sometimes they're one-sided. I guess that's like an artist's choice, right? But at Burning Man, you could definitely see that it works. You can definitely like throw your hands up and have them be like 8 times as big as your body, and that be an amazing experience. Scale is like a really fun parameter to play with when it comes to eliciting weird feelings in people. So yeah, using technology to kind of trigger our own awareness of our senses, depth perception of space, scale. I almost honestly like to think of it as kind of like tearing a hole in reality, and kind of getting a peek at like what's beyond the veil or like the facade, literally, right? And also kind of just from an imaginative space, there's so much we can do with that, especially these days. Like everything feels so unreal, so surreal, like whatever your brand of real is at the moment. There are all kinds of conversations floating around about, I don't know, how we're living a simulation or whatever. And again, like however you might approach that flavor of thinking, I find it just kind of interesting to play with these concepts in a more tangible but fantastical kind of way, I guess. Like make it fun, make it colorful, approach things playfully, highlight the ways that we can use technology in more playful ways that connect us to ourselves, because we get to decide how we use it and what we make with it. And working with 3D and XR and like all the gadgets and devices in that way, like rethinking how we can kind of be in this overlap and how we can move within it. To me, it's a very free and open kind of space, or at least like it can be. It's really up to us, like how we choose to use the technology at our disposal, and what we choose to kind of explore with it. So yeah, for me, I choose, more of a playful, intuitive kind of space, and just, opting to push back a bit, I guess, against all the ways that we use technology against ourselves, consciously or not, and just kind of choosing to flip the script in my own little way and putting technology at the service of our senses. So yeah, thank you for coming to my session. I appreciate you taking the time. All of my info, if you wish to come find me online, is on this slide. And yeah, feel free to hit me with any of your own questions or any questions my questions have maybe made you think of.
Hi, my name is Zach Lieberman. I'm an artist based in New York, and I'm super excited to be here, to be a part of GitHub Universe, and talk to you today about poetic computation, where specifically what I mean is how can we use code in the service of making art, in the service of making poetry. Quick introduction, I used to look like this. I studied art. I spent all of my time in the printmaking studio. I was really happy. I had to get a job, and everybody at that time was talking about web design and Y2K, and the world is going to end in the year 2000. So I applied for a job, and while there, I discovered a tool called Flash. And usually I'm in a live, giving a talk in a live venue, and I'll say, who remembers Flash? And I'll see a lot of hands go up. Flash was this amazing tool where you could do animation on the web, you could do keyframes, and with very simple, you could make things move and with very simple techniques. But the other thing that Flash allowed you to do is write code. It allowed you to write a line of code, a single line of code, like position.x equals position.x plus 1, and then the object would move across the screen. And for me, there was something so amazing about turning language into movement. And a lot of my work kind of continue in this direction. Do all kinds of projects. This is a collaboration between 5 artists and a 6th artist named Tempt. We work together as a team. Tempt is an old school graffiti artist from LA who's completely paralyzed, and we work together to build an eye tracking system that uses the movements of his eyes to draw graffiti. So here we're taking building a tool to allow him to draw graffiti again. This is a project that we did with Toyota where they have this small car, people think you can't drive them quickly. So we put colored dots on top of the car and wrote software to track it and hired a stunt driver to drive letters of the alphabet. So made a font completely out of driving. This is a project we did in New Zealand where we took your body as a starting point and then showed your body but turned into a monster, 3 or 4 stories high. A lot of times the projects that I do involve the body in one way or another. So for example, this is taking your movements and then working with my friend Daito Manabe. When he's making movement on his face, he's creating shapes and the shapes come off and bounce down his face. So the idea is to kind of take your, create almost a new form of mask. This is a project called Manual Input Sessions that takes an overhead projector, so the kind of projector that your math professor would write notes on, and a digital projector, and combines them to create a kind of hybrid light source of both analog and digital. So when you make a shadow, it fills in with color, and when you let go, it makes a sound. In addition to making art, I'm also a teacher. I helped start a school called School for Poetic Computation that's based in New York. I also am a professor at MIT in the Media Lab where I run the Future Sketches group. And in terms of teaching, one of the things that I think a lot about is how do I take the things that I'm learning as an artist and bring it back into the classroom? And for me, open source is a really important part of that. So I helped create a tool called Open Frameworks, which is a C++ tool, an open source C++ tool that makes it easy for you to get started kind of experimenting with video and audio and typography. And it comes out of projects like this, Messa de Voce, where we're with 2 singers trying to imagine what the voice would look like and bringing those ideas back into the classroom. And oftentimes I think about open source tools as almost kind of building blocks that with some combination, you're taking all these pieces and smashing them together and see what happens. One project made with open frameworks, which I really love, is called Delicate Boundaries by the artist Chris Segru. And what she's doing is taking, there are these bugs on the screen, and when you hold your hand up to the screen, the bugs actually come off the screen onto your hand. And for me, there's something so beautiful about seeing artwork leave the screen. We always talk about leaving the screen. And here, when you actually kind of come up to the screen, these elements come off the screen onto your hand and you hold them. And to me, there's something so beautiful about this idea of just making things that leave the screen. As an artist, I'm really passionate about drawing. My background is in fine arts, and I constantly struggle with the idea that drawing on a computer just doesn't feel like drawing on paper. Right? If you've ever had that experience of kind of drawing with ink or with pencil, and then you go to use Photoshop, those tools are not the same. They're not equivalent to what you have in the natural world. Then, as an artist who works with technology, I want to ask the question: what are new forms of drawing that you could do with computation? So the first project I want to show you called Inkspace, and it's using the accelerometer of your phone. Your phone has all these amazing sensors in it. So you can draw on a 2D surface, but as you move your phone, the drawing moves in 3D. And what I love about making these kinds of tools, when you put them out in the world, you can see all of these beautiful things that people do with them. So sometimes very silly, childish things. But for example, this woman in South Korea drew this bird, and for me, it was so beautiful. I had no idea how she could do something like this. And just to see that you build a tool, you see all these kind of amazing things that people do with it. Or this is a project that we did with Google. And Google came to us and they said, we have all these beautiful satellite photographs from around the world. What are interesting ways of interacting with them? And we designed a tool where you draw. So it's a website, and when you draw a line, it'll find that line from somewhere in the world. Or if you draw a curve, it'll find that curve. If you draw a straight line, it'll find that straight line. If you draw an angle, it'll find the angle. And the whole idea is to build this very intuitive interface that uses your gesture and your expression and connects you with photographs from around the world. And projects like this, they have this, pretty front end, but they're built on software. So, for example, Pixie.js is an amazing library for doing animation and interaction on the web. And also even things like vantage point trees, where we're really thinking about kind of data science issues when you're trying to do pattern matching. And you have, for example, you draw a Z, trying to find things that look like Z, and thinking about kind of metrics and distances and, pattern matching algorithms. So a lot of times, even though you see this sort of front end in the work that I do, there's a lot of back end, which is really interesting and hard computational problems to solve. The second part of this project is connecting the dominant line. So taking like a coastline or a highway or a river or the edge of a field, and as you drag with your finger, just stitching them together to create almost a kind of infinite canvas where you're taking photographs from all over the world and making a kind of a new landscape just based on gesture and movement. The last drawing project that I want to talk about is called Reflection Studies, and it's inspired by this student that I had named Yuki Yoshida, who was making a booklet for his final project. He wanted to collect all of the various algorithms that you can use to tell a computer to draw a circle. So it's actually not that simple to draw a circle. There's a lot of different code, different ways of writing it. And I thought of a way, and I told him, and then I coded it to show him. And the general idea is you start with a rectangle, the boundary, and you pick a random side, so one of 4 sides, and you pick a random point along one of those 4 sides, and you connect it to a random point along one of the 3 other sides. So now you have a line. And if that line doesn't intersect the circle, you draw it. But if it does intersect the circle, you don't draw it. So in a way, it's a form of drawing by absence. You're only drawing what is not a circle. And the more lines you draw, the closer you get to approximating a circle. And I got so excited about this idea that I tried the word love. I tried a smiley face. And then I was thinking, what if those lines were like And what I like about projects like this is that they're immediately understandable. You come to it, you bring your body, but then it almost kind of starts with your body, and then it goes back to your mind, and then back to your body. And this pathway I find so beautiful. And by the end, people weren't even using the shapes. They were putting it down. And I just found it I just love this kind of project where you invite people to take your sketchbook and bring it to life and bring their creativity to it. A lot of projects that I do involve the body in one way or another. So, and specifically the field that I'm really passionate about is human pose estimation. How can you understand where a body is in space? And then we can take that data and use it to drive animation, to drive art and design. And in general, you think about this almost as a kind of trying to find a skeleton. So given like a picture of a person, where are the elbows? Where are the wrists? Where are the hips? Where are the knees? And then you can use that data in really interesting ways. So for example, this is taking the body and adding like almost a kind of digital costume. This is my partner Momokwo, and we've been developing these kind of almost kind of performative costumes. This is another example of that, where you see like a costume coming to life. And I think there's something really beautiful about just even thinking of human motion and what does it feel like to track movement. And if we can visualize it, then we can understand the kind of beauty and poetry of body. This is taking a dancer on the street and just trying to understand her contour and the velocity of her contour and draw it and kind of in an interesting way, or create a situation where she can paint with her body. And it's her movement that brings the city to life through her gestures. And I'm really interested in the body as a starting point. So specifically, what happens if you take the body and rotate it and revolve it? Do you still see a person? What would it look like to connect things to the body? Or even just take like a circle and draw around the body and see what it feels like. Do you still see a person there? Do you still see a human form? This is a project that I did with the New York Times, where for this article, we interviewed hundreds of addicts and asked them, what did their body feel like when they went through addiction? And then we commissioned a dancer to dance those responses. So she interpreted the language that these addicts were telling us, and she dances it out. And to me, there's something really amazing about the movements. We wrote software to track the body, to get contour, to track the data points, and then try to figure out what is the visual language that we could use to really show what the body feels like when you go through addiction. So the way this article works is that when you scroll through it, there are these visuals that we've created. So for example, this is Gateway, where you see what the body, this is what you feel like when you start to take the drug. And Tolerance, when your body builds up a kind of tolerance for the drug. This is Withdrawal, which is what you feel like when you stop taking the drug. Addiction, when you keep having to take the drug in order to maintain a sort of baseline. Treatment, which is what you feel like when you start taking medicine to deal with addiction. Relapse, which is what you feel when you start taking the drug again. And finally, recovery, which is what you feel like when you've gone through this and you start to feel your body come back to itself. And the most beautiful part of this project is at the end, there was a form where we asked people to tell their own story. And we collected hundreds of more stories of former addicts, and just love the idea that this project sort of started with conversation and leads to more conversation. Another project that I want to share about the body is called Más que la cara, which means more than the face. And it's a public art installation in downtown Houston. And it's inspired by this spread in this book by Bruno Munari called Design as Art. And in this spread, he's showing you the various, like how simple it is to represent a face, that you only need just a few visual elements, like of the eyes and the nose and the mouth. And our brains are so wired to see faces that it's really easy to make out a face. And there's also a concept of pareidolia, seeing faces in things. There's a museum in Japan of rocks that look like faces. I really want to go. And I want to go see the rock that looks like Elvis. That's like super my dream to go in the future. And in general, like, what does it mean? What do masks mean in culture? What does it signify that we wear masks, and what are we celebrating? And when we worked on this project, we were going to downtown Houston, and every time we went, we would do workshops with local school children. And for me, there was something so amazing about hanging out with school children and making masks. We laser cut all of these pieces of cardboard. We geeked out. We made masks together. And then those ideas informed our software. So we took those ideas. We wrote software. We were using a tool called Paper.js. This is a really beautiful JavaScript framework for doing kind of beautiful animation in Canvas. And we created these forms that are very simple, that are just based on kind of this simple graphical ways of representing the face. And the way this project works is you approach it, it's almost like a living poster. When it finds your face, it zooms in, and then your face becomes a kind of backdrop for a living poster that there's graphics on top. So, and it's so beautiful to see how people interact with it and kind of see their face in a new way. See their face as a kind of backdrop for a graphical form. We did all kinds of things, very silly things. Here's me saying what I just said to you, but you can get a sense of this this installation, kind of what it felt like to use it. It was just really exciting for us to take these ideas and then bring it out on the street and see what people do with it, and see how people interact and explore with their body and with their gesture. The last thing I want to talk about, and then I'll talk about school for teaching for a little bit, is space. So specifically augmented reality. What does it mean that we can know where a device is in 3D? To me, that's so beautiful to think of a camera in space, a screen in space, a speaker in space, and a microphone in space. I think there are all kinds of beautiful interactions that we can create with that. So for example, this is taking photographs, and the photographs stay in the air where you took them. So this creates almost a kind of fragmentary image. And to me, there's something so magical about kind of photographing the world, but having the photograph hover where you took it. And then you wind up kind of seeing the world from these different perspectives, or recording frames of video in the air. And then when you're done, they sort of float there, and you have to use your body to scrub them. So with your body, you're almost like the playhead for the video, and you go back and forth and control the speed of the video through your movement. This is taking photographs and exploding them in 3D. So there's one vantage point where the image looks correct, but if you move, it starts to become kind of like a cubist composition. This is a slit scan technique where you're taking the colors, the pixels that are in front of you, and painting with them with the air. So almost taking elements from the world and bringing it back into the world, having a conversation with the world through the system. Or taking photographs and pushing them, so there's one vantage point where they look correct, and then as you move, the image starts to seem warped. And I think AR is just such an interesting vehicle and mechanism for ambiguity, for creating moments and situations that are just visually ambiguous. This is recording audio in space. And then when you walk, it replays. This is a test of talking and seeing what happens when we record audio in space. This is a test of talking and what happens when we record audio in space. When we record audio. And my partner Momoko and I have been developing different apps. Like we have an app called Weird Type. This is an app called Weird Cuts, where it's like taking collage. You take elements, you cut elements from around the world, and you can put them back in the world in 3D. So it's a kind of mechanism for capturing and collecting and making augmented reality. And we use it in all kinds of ways. We make funky portraits. A lot of times in the studio, we're doing things like taking photographs of our eyes and nose and making kind of unique portraits. And I love when you put out tools, seeing what people do with them. So for example, this is a sandwich where somebody took all the elements of the sandwich and put them, in 3D, like exploded them out in 3D. And we're doing a lot of experiments with the body. So trying to understand, what does it mean to have the body in space? So it feels like you can create almost new forms of portraiture with augmented reality, and also understanding kind of where the human form is. Or taking the body and cutting it into pieces. And then as you move, you can leave a trail, and the trail sort of hovers in the air where you were. Or even doing things like recording sequences of movement and looping them. So you're creating almost a kind of like a playback, or like an animation system with the world. It's very trippy. It's very hard to understand. Or doing things like taking the body and understanding, taking your gestures and you're kind of weaving and creating 3D forms with your hand movements, taking the body as almost a kind of vehicle or instrument for painting. Here's similar painting, but now like a chrome shape. And as you move your hand, you make this kind of chrome form. And my studio mates are very patient with me. I'm constantly running around, filming, trying to figure out something that looks cool, and saying like, oh, what if we filmed you from behind and you moved and we made a tunnel, and like, what would it look like in the tunnel? And it's just experimenting in the studio every day. And finally, most people think about augmented reality as adding a layer onto the world. But I also think it's really beautiful to think about removing things from the world. So here we're trying to remove a person. And I think this is really beautiful, this idea of, through software, what can we do and how can we understand privacy? Most software is about trying to, understand the body and to understand, and surveil. And I think there's something really beautiful about kind of taking those technologies and thinking about how can we build tools to make people anonymous, to hide people or abstract them, so we can tell a different story. We can tell a different story about our bodies and them in the world. The last thing I want to say is that I'm a teacher. I'm a professor at MIT. I also help start and teach at a school called the School for Poetic Computation. And at that school, we are fascinated with the intersection of electronics, code, and theory. So for electronics, you're learning about gates, you're learning about the kind of basics of computation and building computers from scratch. In code, you're learning about creative coding, and in theory, you're learning about reading and writing around art. And all three of these things we focus on in service of making poetry with code. We do a lot of cooking and eating, and I teach a class there which is called Recreating the Past, and it's inspired by this book by Osamu Sato. Osamu Sato is a Japanese designer, and I'm going to share this book with you. He made a book in the 90s, which I really love. I realize this is not professional, but I love just sharing random stuff in my talks. This is an amazing book, The Art of Computer Designing, from the early 90s. And I love the aesthetics in this book. It's all about how you can use the computer and all these different kind of techniques of rotation and symmetry, and using them for making art, using them for drawing. And I fell in love with this book. I read it cover to cover. I got so excited about all of the visual ideas in this book. And then at the end of the book, the book gets crazier and crazier. And at the end of the book, he's thanking people. And he said, in the afterword, he's thanking people. He said, I would like to acknowledge my favorites, Russian avant-garde, Futurism, and Bauhaus, whose brilliant typefaces and designs have in many ways shaped my own mind. If the artists of those movements were alive now to work with computers, I'm certain they would discover new artistic possibilities. The work of past ages accumulates and is remade again. And I think this sentence is so important. The work of past ages accumulates and is remade again. And I think this sentence is really powerful because it suggests that the past is there for us to engage with. And for students, I think in particular, it's a gift to say that you can recreate the past. You can have a conversation with the past. But also it's a gift, it's an obligation to create things that that engage with the past, that to take things from the past and recreate them using today's voice, today's tools. So, for example, in my class, I teach about different designers, like Muriel Cooper, who was the design director at MIT Press and had to help create the MIT Media Lab, and had a group there called the Visual Language Workshop. And her group was focused on the intersection of typography and computation. And for me, there was something so beautiful about her work, studying her work and the work of her students, and then my students recreate her work as homework. Or Vera Molnar, who's a Hungarian artist and designer, and she's been doing pen plotter drawings since the 70s using ALGOL and old school languages. And my students take her work and study it and recreate it. They have a conversation with it. They reverse engineer it and they recode it using modern tools. And we were invited to show our work at a festival, and we suggested showing the code and the visual side by side. So most times when you see artwork that's created with code, you only see the output. You only see the visuals. You never see the underlying code. Or when you go to a website, you could say view source, but you never really see the language, the thing that makes the thing. We wanted to show these at the same time to make them equals. So for this exhibit, we set up LED screens where we have text and visual side by side. And what you see on these screens are homeworks that my students made. And we also made a zine so you could learn about these artists. So you could see the homework, but then you could also, through the zine, learn about who are the artists that inspired this work. You can hear kind of like typing. And you can even see these moments where you see the text, the numbers change in the code, and you could see a corresponding change in the visual. And the whole idea is to, even if for people who don't know coding, for them to feel this relationship between language and form, for them to feel the poetry of text turning into visuals. That's what we were trying to do with this installation. And the last thing I want to say is, it's obviously a really strange time. I'm speaking to you virtually. We're in a virtual conference. We're all going through this COVID situation, together. And I was walking down the street, a while ago, and I saw this graffiti on a building in Brooklyn where I live, and somebody written the word COVID-19. And I thought this was so terrible. It was like being in a really cheap science fiction movie where there's graffiti on the wall to tell you, to kind of, give you environmental graphics so you understand what's going on, or like a video game. I just felt it was so stupid that somebody had written COVID-19. And I was walking down the street the other day, and somebody had crossed all that out and written the word hope. And that gave me a lot of hope, and I hope it does for you as well. I just want to say thank you. It's been really my pleasure and honor to be speaking to you today. Excited that you're taking part in this conference, and happy to answer any questions. Thanks again.
Hi, welcome to this talk about WebXR and what it means for the future of the web. My name is Jaume Sanchez. I work as a UX UI engineer doing visualization at DeepMind. I've been coding on the web for many years using WebGL, WebVR, and now WebXR, both professionally and as a hobby doing creative coding. I'd like to thank GitHub Universe for the opportunity to talk about WebXR, its state, and its exciting future. So what is WebXR? Simply put, it's a JavaScript API to use XR devices. Cool, but what does that mean? It's a way for web pages to access an XR device's inputs and outputs. XR is a term that covers VR, virtual reality, AR, augmented reality, and MR, mixed reality, with the X being the thing, the unknown, the variable in the equation. It's also usually referred as extended. Hardware that enables XR applications is now broadly available to consumers, offering an immersive computing platform with new opportunities and challenges. WebXR allows any web developer to explore these opportunities and challenges from the web. So, as many talks about the future, there has to be a recap of history to understand how we got here and how it shapes the way it progresses. But I'll be very quick because everything that led us here can be forgotten and start anew. Basically, it started with adding browser support to the Oculus DK1, which was a rotational controllerless HMD, which means it wouldn't track your position or have ways to interact. That experiment became really interesting and powerful, and a great stepping stone for bringing VR to the web. As new headsets came, the Cardboard, Gear VR, Vive, Go, it became obvious that WebVR wasn't well conditioned to evolve with quickly changing hardware, with new patterns and developers' expectations. So WebVR 1.1 shipped in some browsers, got deprecated, and removed in some engines. It was time to do something better with the lessons learned. This new thing is WebXR. It's a new API that fully replaces WebVR. It came to be after listening to developer feedback, all the confusing or inefficient parts, the pain points while developing, iterating on emerging best practices and patterns. So it's now more flexible and future-proof. It maps better to XR hardware, the new patterns to the users and developers' expectations, like low latency and high refresh rate. It provides improved support for input and output. We now know more about the devices, which greatly simplifies rendering to them. Enables a unified input model with standardized layouts for buttons, triggers, touchpads. And for instance, we can now get 3D models of the controllers from a content delivery network. No need to host them or keep up with them. It also brings a better understanding of the user space to know if we are dealing with Cardboard that can only rotate, or Vive that can move around inside the boundaries of a Guardian, or an AR experience that can move freely all over the world. It also provides performance improvements, mostly supported by the backends, like faster and better rendering or video decoding. And it enables a shared code path for multiple outputs. The code for inline, Magic Window, AR, VR app doesn't require much branching now, which greatly simplifies development. WebXR is under the Immersive Web Working Group, which is a W3C group. This is important because it means there is a roadmap, so the implementation won't be changing under your feet. WebVR was a bit more loose on its approach of trying things and see if they worked and were adopted. WebXR is an independently designed standard with lots of similarities to OpenXR because they try to tackle the same problems and similar landscape. So there's a mutually beneficial feedback loop between both APIs, but it's not like OpenGL and WebGL. The API is different, but most backend implementations follow the OpenXR spec. Being a working group with a spec means that new features can be supported fairly quickly because there's no need to figure out anything or reverse engineer. It improves on the early adopter nature of WebVR, and it's backed by the industry. We have Google, Mozilla, Oculus, Microsoft, Unity, and many others behind. All the activity of this group happens in GitHub, so you can go and check it and contribute. So what is WebXR for users? It means that you can enjoy VR and AR content the same way you consume any other content. Can you imagine a web without embedded video players? There was a time when that was also experimental. So practically speaking, it means that a web page can offer the option to go into VR or AR, track controllers if they are required with the security of the browser sandbox, no download and installation of apps with EV permissions, just hop on virtual environments without leaving the browser. Pages can go from flat to surrounding worlds in an instant. Experiences can go from amazing 360 video, which are still massively popular with Cardboard users, to furniture browsing, chemistry analysis, games, anything you can imagine. So for instance, Mozilla Hubs is a VR chat room and open source project that explores how communication in mixed reality can come to life. And lots of interesting and weird things are happening in this virtual space. For developers, it means being able to develop XR sites and apps with the same workflow as any other web development. The libraries and frameworks you're familiar with, the same simple and affordable cross-platform development environment. You will need WebGL, JavaScript, and some DOM to begin with, but all the web tech can be used. WebAssembly, WebRTC. For instance, in the image MakePad uses Rust to create a collaborative shader editor, which you can also check on GitHub. Your app can benefit from instant delivery and updates with a huge reach of the web, with improved security because it requires HTTPS, no apps to download or install, no store. So what does WebXR provide? So through the API, the page can connect to an XR device, which could be something like a Daydream headset or an Oculus Go, if the user allows its use, and then leads its capabilities. With an XR session started on that device, it can keep querying the pose and send images to the device output. If the experiences requires controllers and there are any available, for instance, like this clicker or the Oculus controller, it also provides access to the pose and inputs like trigger, buttons, touchpads of all controllers, and even access to the actuators, which can provide haptic feedback. So in practice, this is achieved via multiple modular parts. The parts that are actually currently available to everyone are the WebXR device API is the one that actually provides access to inputs and outputs capabilities of an XR device. The content rendered to the devices is provided via WebGL. The gamepads module allows interacting with the buttons, triggers, thumbsticks, and touchpads of an XR input device. The AR module works the same as the immersive VR content, but it guarantees that the user's environment will be visible and aligned with the rendered content. This may be achieved with see-through displays like the HoloLens or the Magic Leap, or video pass-through systems like ARCore or ARKey, which is basically your phone. The heat test module provides information about the real world and a method for developers to heat test against it. It becomes very important for really immersive AR applications, so things can be grounded on the wall. The DOM Overlays API provides a way to show DOM content, such as text and input elements, during an immersive AR session. This content is displayed as a transparent background layer superimposed on the real-world scene and the rendered WebGL content. It's very useful to quickly build interactive AR apps. There are more modules in different stages of design, implementation, and support, and I'll talk a bit more about them later. So what can we build? It's about supporting the immersive web in a responsive way. VR, AR, inline in a regular page, all cases can be supported. You can still apply the principle of progressive enhancement to XR. So building the immersive web can mean experiencing virtual worlds through the browser, virtual content seamlessly integrated in your browsing experience, limitless possibilities through a web platform. It's really all about the future. So how does one get to build the immersive web? You can, of course, just use WebGL and JavaScript and grind through. But fortunately, there are several JavaScript frameworks that support many WebXR features and have a very active community of developers and adopters. In alphabetical order, there's A-Frame, a web framework for building 3D, AR, and VR experiences declaratively with HTML and an entity component system. Babylon.js, with loads of tools and a great IDE. Play Canvas is another great WebGL engine with IDE and WebXR support. And 3JS, very widely used, has plenty of documentation and examples. It also has a very active community to bridge with other frameworks like 3 React or Svelte 3. The 4 of them are on GitHub. You can check their progress and contribute anytime. If you're not a web dev, there are still options to build content for the web and use the power of WebXR. Like some options are Facebook photos and videos with React 360, which allows to create exciting 360 and VR experiences using React. Google Model Viewer, it's a custom element that you can use to easily display interactive 3D models on the web and AR, also on GitHub. Sketchfab is a platform to publish, share, discover, buy, and sell 3D, VR, and AR content. It has an amazing team behind it, and they are developing great tech. Sumerian is a new platform for developers to build and host VR, AR, and 3D apps quickly and with minimal coding. In Unity, one of the most well-known cross-platform game engines, there's an exporter by Mozilla Reality, and other exporters are being developed. And finally, Verge 3D is a toolkit for Blender, 3ds Max, or Maya to create immersive web-based experiences. But if you go the way of building yourself, you have to choose a framework, and depending on your framework of choice, you get support for different key features for XR. This is a general thing with VR and AR. It's not related directly to WebXR, but when looking at a framework or engine, it's important to look for things like locomotion. We've learned a lot since headsets first allowed us to move. High refresh rates have helped with motion sickness, and lots of testing and research have helped improve our patterns for moving around, but we still need to choose or implement a locomotion mechanic for our experiences. In the same vein, physics lie at the core of many immersive experiences because we can believe non-realistic things behaving in a physically correct way better than realistic-looking things behaving unrealistically. Related to that, animation with things like bone animation, skinning, rigging, all are very useful to make things more lifelike. And heat testing, the ability to touch and interact with the world. In VR is relatively straightforward since the scene is all under the experience control because it's created by it. With AR or MR, it's slightly more complicated because information from the real world needs to be fed and processed. There's something related coming up, more on that later. Some more things to consider. Hand tracking, for instance, this has been a recent development in the Oculus Quest, and there's a module for that behind the flag. To be able to use hands with no hardware, the system recognizes hands and fingers, and they can be used to interact with the scene. Once enabled, you get the joints of the different parts of the hand, but the actual rendering of the hand is left to the experience. So you need something that can load the appropriate model and do some bone animation to distort it. Also related input models, as mentioned, there's a repository of controller models that can be used via content delivery network, so you can draw them accurately instead of drawing a generic controller or a box, improving the immersion. And finally, things like text rendering. It would be ideal to have something like CSS and DOM. The layers module that is also coming soon will help with this, but anyway you want to render text, you will need some support for fonts, layout, crisp rendering. So talking about support, basically for VR, you have Android with Cardboard Daydream through Chrome. You've got some Samsung phones with the Android Samsung Internet Browser, and Android Firefox with the Polyfill. The Polyfill is a JavaScript implementation of the WebXR device API, as well as the WebXR gamepad module. It allows developers to write against the latest specification, providing support when run on browsers that implement the WebVR 1.1 spec, or on mobile devices with no WebVR or WebXR support, that's all. For iOS, you can use the Mozilla WebXR Viewer, which is basically a WebXR content renderer. It's not a full-fledged browser, or Safari with the Polyfill. In standalone headsets like the Oculus, you can use the Oculus browser or Firefox Reality, which is a browser from Mozilla that is designed for browsing the open web in virtual reality. And for Windows, you can use Chrome and Edge. There's not many VR options right now for macOS or Linux. Regarding AR or MR, the Android phones with AR Core and Chrome, or Samsung phones with Samsung Internet Browser. And for the standalone with Magic Leap with the Helio or ExoKit or Firefox Reality, and the HoloLens 2 with the Mixed Reality Toolkit and Firefox Reality. And again, there's not many options of AR for Windows, macOS, or Linux. So if you want to get started right now, the best way is probably an Oculus Quest 2 with the Oculus browser for VR, and an Android phone with AR Core and Chrome for AR. So what is this being used for? Or what is being built? Many things are being built right now. Just a few examples. Lots of games and entertainment. Some examples. On the bottom left, there's Moonrider, an open source game similar to Beat Saber, created by Super Medium, the maintainers of A-Frame. Troll Tower by Daniel Esteban. Construct Arcade has a whole set of cabinets to play user-created XR games. There's also space for artistic experiences that combine images, procedural generation, video streaming, web audio. There's a very active creative coding scene. On the top left, we have an example by Within, who have been building immersive experiences for years. What you don't know is an experience on the creative process of Matthew Deere. Also, advertising and campaigns for brands. On the bottom right, Lucian has an AR ad for a fictional sneakers campaign. And of course, education. Virtual visits to museums where you can interact with everything, interactive, collaborative lessons with explorable diagrams and explanations. On the top right, Frame, that lets you easily meet and create with others in private 3D spaces, is now focusing on virtual classrooms. More options for commerce. You can see objects close up before buying them without visiting the store. You can see customized versions of anything you want to purchase, place it in the wall, place furniture in your house and see if the colors match. Play Canvas has examples for AR furniture. Shopify supports the model viewer. Sketchfab is widely used. More cases in this age, real estate companies and house hunters can usually benefit from virtual tours to houses. For productivity, all the collaboration, measurements, finding directions, create presentations, all kind of useful tools. There's Nifty Reality. It's a virtual reality space on the web that lets you run multiple 3D applications at the same time. Or SODAR by Google that uses WebXR to help visualize social distancing guidelines in your environment. And of course, research with things like protein and molecule viewers, multidimensional data exploration and visualizations, AI agents training. For example, at visualization in DeepMind, we use WebXR to be able to review agents in their training environment with metrics and analytics, and even interact with them in AR and VR. But it's also about building the metaverse. The web enables connectivity and sharing, and so you can think as of a potential explosion of content like GeoCities and Flash. We have examples like Dracosis, a 360 volumetric video by XR Social and X3 Engine. Lots of things happening in hubs. Fabien Beneteau shows live coding in a virtual room with multiple viewers as he streams while coding a light switch in a VR environment affecting a real-world Internet of Things light bulb, all happening in VR and over the Internet. We've also seen multiple actors performing live from different cities in future stages on Mozilla Hubs, or we've seen Valence James dancing over live stream volumetric video into hubs. So things are coming soon. New features that are here but behind the flag, which means they will be soon available for everyone. Hand input module exposes the poses of hand skeleton joints. It can be used to render a hand model in VR scenarios, as well as perform gesture detection with the hands. It does not provide access to a full hand mesh. That's where the frameworks become important, as we said earlier. In the top image, you can see how Three.js supports hand tracking and rendering out of the box. And on the bottom image, sign language detection by Handy.js by Stuart Smith. Also, Layers SDI that brings composition layers, which are useful for displaying information, text, video, or textures that are intended to be focal objects in your scene. It improves performance and battery life with enhanced visual fidelity. You can render images, stereo cube maps as backdrops, and more. On the right, you can see a preview of how Supermedium, a comic book and magazine either for XR, uses layers to greatly improve fidelity and performance. In progress also are some really nice features. Depth sensing exposes information about the distance from the user's device to the real-world geometry in the user's environment. You can see it in the first image by Maxim Zmihiev for Play Canvas. The digital rabbits are partly occluded by the physical table. This is huge for immersive AR since it gives better heat testing and object occlusion. Also, image tracking recognizes user-specified images in the environment and provides tracking information. In the center image, also by Maxims, you can see a cube and a digital book cover that are attached and tracked with a real book cover. Lighting estimation that provides information for the renderer to improve shading, shadows, reflections, so content appears more natural and integrated. Brandon Jones shows us how the XR dinosaurs are integrated better in their environments using that new information. And also more things like access to the camera on top of the AR SDK. It will provide extra power to the user by applying computer vision or artificial intelligence to the feed, like detecting hands or faces, which do not necessarily fall under the responsibilities of the AR layer. And finally, DOM to VR. Similar to the DOM overlay for AR, VR developers have long wanted to be able to use regular web content in their VR environments. This is very important because it will make much easier and seamless the integration of content with XR. And many more new features that are coming soon, not directly related to WebXR, but like improving the ecosystem, like WebGPU, which is designed from the ground up to efficiently map to modern native GPU APIs. WebGPU is not related to WebGL, and it's meant to be its successor. In the future, it will be used to provide the render content to XR devices. Progressive Web Apps, PWS for short, are web applications that have been designed so they are capable, reliable, and installable. These three pillars transform them into an experience that feels like a platform-specific application. Bring this to VR and you'll be able to start web apps from within the shell like if they were native. And more adoption in the future, there's a bunch of new HMDs for both VR and AR coming up. New uses, new accessories, new features. In the image, you can see a promotional image of Facebook's Infinite Office, a set of tools to improve the virtual office experience. You can see how it's a browser and Visual Studio Code, which is built with web tech. And maybe the future will see more browser engines implementing WebXR. So talking about the future, what does the future hold? We know many brilliant, interesting things are being built, but what could it look like for any web user? Some of these ideas are just ideas, some are being actively researched, and some are even developed as products as we speak. Maybe there can be a web of such simple and tangible things as 3D objects, which can be seen in VR or placed in AR with some hot areas or script buttons, which link to other similar objects. Sketchfab and Facebook photos have already showed us that it's a viable format. We may see a return of web rings where people place their content online and link it in a Gibson-esque way. An object can be a small cube, but it can also be a whole room, all shared and interconnected via the web. Another interesting thought, can the web core technology, HTML, grow to embrace XR? We saw HTML5 bring the standardizations of many new tags, which have enabled amazing experiences that nowadays we take for granted. Same with CSS3. Can we look forward to a full valid markup supported by the browser to build XR experiences? And at the same time, we need a way to consume content that is not ready for VR or that doesn't need the third dimension in general, but it could benefit from it. Wikipedia is a 2D scrolling experience, but illustrations and graphs can be 3D and interactive, like read along an article as objects and projections whiz by. We could find a way to build even smaller components than PWAs or turn PWAs into widgets that we can place around in our virtual space. Notes, calendars, videos, social feeds. We could consume a vast array of data with small adapters for all our web content. Could be the return of microservices, could be the return of active channels or Yahoo pipes. Aardvark, for instance, is an augmented reality layer that incorporates multiple applications or gadgets on top of existing VR worlds. And finally, stepping out of the page back into the browser. Can a browser be an XR experience in itself? Can it transcend the 2D projected window and be a shell on its own? How would that work? Right now, we know in VR our whole view, our whole world has been replaced, rendered by the experience, and we have to go back to the shell to be sure we're safe. That's why there's no link traversal yet. A malicious site could try to imitate your shell and try to fish some confidential data. We've developed all these UI notions like the padlock for secure connection that live in the browser Chrome, in the area outside of the page. Where do they live when in VR? When the page, the Chrome, the browser are not there. Is there a physical manifestation in the VR world? Is there a companion hovering near you that you can talk to, like an assistant? Will XR be interacted with mostly via voice? Some gestures could bring a safe bubble inside any VR experience where you know nothing can render on top of the browser, like a meditation gesture to move all the virtual content away and get out of the matrix. So, of course, all this opens new questions for which we have very few solid answers. How do we deal with accessibility? Not only text readability and contrast factors, but how can a screen reader even work on VR or AR? Can we afford to make experiences that discourage visually impaired users or make a control or locomotion schema that can't be used by physically impaired users? Or something as simple as making experiences that don't account for left-handed users or children? As we mentioned before, with the risk of traversing VR content, how do we tackle security? What patterns can we develop that make it secure and safe? Can we let kids go happily browsing with an HMD? More so, how do we bring forward the extensible web? Make sure that any developer can easily use all these components and extend them instead of using black boxes. These are all questions that need many people to work on them. The great thing of the web and WebXR is that many of these problems can be explored quite easily, and the explorations get huge reach with little complication. So that's it. Go explore right now if you're interested. Head to Immersive Web, github.io, and check it out. Start building anything your mind can come up with. Let's go build the future. Thank you.
Hi, my name's 2XAA, or Sam Ray, and I'm going to be playing you some music from my Nintendo Game Boy Advance. I use some software called Nanoloop 2 to compose and perform music, usually quite upbeat electronic, but today's going to be quite a slow, relaxed, chilled out set. There's going to be 3 tracks, and we'll have some audio-active visuals from Alithia_net. So, let's get started. I hope you enjoy.
everyone. My name is Benedetta, and I'm a co-founder and software developer at Ponycode, which is a startup that helps developers code better using artificial intelligence. As you can imagine, machine learning and NLP in particular are very important topics for us at Ponycode. So today I'm here because I'd like to explain some of the key concepts from these topics. This is meant to be very much of an introduction, so it's suitable for people who have absolutely no pre-existing knowledge of both ML and NLP. But if you do know lots about these topics, it might still be worth staying with us, because I can guarantee that it will be a little bit different from other introductions to ML that you might have seen. Because to make it a little bit less dull, I've decided to present it to you in the form of a story. So let's imagine that we have a big tech company where lots of developers work. And over the course of 2 months, lots of developers start calling in sick for reasons of stress. And a few of them actually end up leaving. They receive a lot of resignations. And the reason that they all give is that they're unhappy at their job. They were all really talented. So this is terrible news for the company, obviously. And the HR department realizes that they absolutely need to do something about it. They need a way to predict if the developers are happy or unhappy so that they can act before they receive a letter of resignation. So what they do is that they go to the CTO of the company and they ask him to help them. And the CTO, being a massive machine learning fan, he decides that he's going to take this opportunity to practice his skills a little bit. And he decides he's going to provide the HR department with a model that can predict which developers are happy and which developers are unhappy. So he starts thinking. He knows that the first step in any machine learning application is deciding how to represent your data points. So in his case, the data points are the developers. So he says, okay, I'm going to keep it simple and use just 2 parameters. So he starts thinking, what could I use? But maybe beauty and charisma. Maybe, they're not happy because they're not very beautiful and not very charismatic. But then he looks at his developers and he realizes that surely this is not a good metric in his case, because all his developers are really beautiful and really charismatic, like most developers are really, we all know that. And so he starts thinking again, maybe I can find something better. Maybe I could look at their code quality. So if I take the coverage, the test coverage and the documentation coverage for each developer, maybe I could find a pattern there. So he looks at the developers and realizes that actually there is a pattern. And you can see that clearly these representation dimensions are quite helpful. And it turns out, that saddest developers actually were the ones that had the lowest quality code, and happy developers were the ones that had really high quality code. So this is what he does. He decides to represent each developer using a vector that is made up of 2 dimensions, so documentation coverage and test coverage. And for each of them, he also assigns a label that is a strict label, so either happy or unhappy. And all this data constitutes his training data. At this point, he can feed all this data to a machine learning model, finally. And in this case, he uses a classification model and decides to train it. Now, the job of the classification model is to divide the representation space in a way that maximizes the number of developers that are classified correctly for our training set. So in our case, which is very, very simple, we see that this is simply a straight line. But of course, it can be much more complex in reality in other examples. So using this system, the HR department can predict which developers are happy and which developers are unhappy. And overall, it does a pretty good job. Now, I know what you're going to say, that of course there are going to be mistakes. Of course, there's going to be some developers that are sad, even if their code coverage, test coverage and documentation coverage is good. And at the same time, there's going to be some developers that are happy, even though their code quality is very low. But this is the thing about machine learning models. They are, at the end of the day, just statistical models. So we can't expect them to be right all the time, as long as they're right most of the time. So I'd say that overall, this is quite a good thing for the HR department. But then a month goes, and the CTO receives another call, and it's HR again, and they say, actually, we're not happy with this. It's not enough. It's too black or white, this system, and we just end up having developers put in boxes where we know that they're either really happy or really unhappy. But in reality, some developers just lie in between. And they might not love their job with a passion, but they're not completely unhappy, and they're definitely not close to resignation. So they suggest, why don't you give us a happiness score instead? So each developer would be assigned a score from 0% to 100% of happiness. And hopefully this means that HR has a bit of a more nuanced vision into how close a developer is to leaving the company. And they can adjust on the cases that are very urgent. And so the CTO starts looking at his developer and said, okay, I think I can do this. I think I just need a different model. So I'm going to use a regression model. So once again, he starts preparing his training data, which uses the same metrics as before, so test coverage and documentation coverage. But instead of a categorical label, so happy or unhappy, he labels each developer with a percentage. So for example, 35% happy. And he also chooses, like I said, a different type of model, which is called a regression model. Now, what a regression model does is that instead of giving us a discrete value, so categorical, happy or unhappy, it gives us a continuous value, so a degrees of happiness. And on the representation space, the effect is that instead of having a clear division between two opposite areas, we have this kind of gradient that I represented here with colors. Now, in the same way of classification, this model learns the mapping by looking at the training data. So the mapping maximizes the prediction of the correct happiness value for all developers in our data set. So now we have a model that takes the test coverage and the documentation coverage for each developer and identifies how happy they're likely to be from 0% to 100%. So for example, Grace here, who has impeccable test and documentation coverage, will be classified as very happy, while poor old Alan instead is down at the bottom because he doesn't like to document and to test, so he's considered to be very unhappy. And the big improvement here is for all of those developers that are lying in the middle. So previously they were classified either as a 0 or a 1, and now we can say they're kind of like 50% happy. So CTO is happy, he gives this new model to HR, and for a while everything goes well and they have a nice way to categorize developers. But one day, one of the developers finds out that this has been happening, and he tells all the others, and they all go furious about the fact that they've been categorizing them this way. They say, we're not just figures on an Excel file, this is unacceptable. And because they're French, they work in a French company, they decide to go on strike. They say, we're not coming back until you find a more human way to find out about our well-being. And their representative proposes that maybe they should be able to send emails to the HR department to tell them how they're feeling. And the HR should use these emails to make their judgments and act when it's necessary. Immediately, HR is inundated by emails, and they realize there is no way they will be able to do this job manually. So once again, they go to the CTO and ask him for a way to help them in the process. The CTO says, no problem, okay. But at this point, he's become so obsessed with the fact that code quality equals happiness at work that he uses this criteria to label all the emails that the HR department starts receiving. So his training set. He labels all the ones that talk about testing code with various degrees of happiness. So kind of like, let's say 50% to 100%. And instead, all the ones that, where the developers confess that they are not big fans of testing, he says, okay, this must be 0% to 50%. And he has the problem now. What is his data set? So his data set is very different from what it was before. Before, each developer had a vector with a score of documentation coverage and test coverage. But now all he has for each developer is an email, which is essentially natural language. So he realizes that he needs to use NLP, and he's very, very happy because he's never used it before. So it's his first time. he decides to apply techniques of sentiment analysis to detect if each developer is happy or unhappy, based on his email. Now, before you comment that sentiment analysis does not cover the whole of NLP, this is absolutely true. It's only one of many tasks that NLP can do, but I decided to use this as an example because it's for the sake of simplification, but also because many techniques used in sentiment analysis are actually the root of NLP as a whole. So let's get back to our story. And actually, my screen froze for a second. Let me get back to it. Okay, yeah, I'm good. So the first thing the CTO needs to do is to break up these emails, all the emails that are in his data set, into smaller units, so that processing will be a little bit easier. And this process in NLP is called tokenization. So in our case, we consider our words to be our tokens, which means that in a sentence like, I always test my code, we'll end up with, I always test my code. The advantage of tokenization is that whole emails are unlikely to be repeated. So we're not going to receive the same email twice exactly. But often the same words do appear in different emails, in different contexts. And this allows us to find some points in common between emails. Now, the CTO notices immediately that sometimes there are small mistakes or differences in how a word is spelled, and differences between uppercase and lowercase, and he realizes it's in his interest to remove these discrepancies because it doesn't look like they add much value to the meaning of the sentence. So he decides to do a little bit of pre-processing, and he transforms everything into lowercase, which means that we end up with a slightly more limited number of unique tokens. And we can identify the same word even when it's capitalized in a different way. Then he notices that there are some words that are used in different, maybe some verbs that are used in different sentences, in different tenses, in different sentences, or some adjectives that are used sometimes as singular, sometimes in a plural, and it would make sense to reduce those just to the essence of what it is. So what he does is he breaks down all these words where he notices this behavior, and he breaks them into subwords. Basically, in most cases, he just separates the root of the word from a suffix or a prefix. So like testing becomes just test plus ing, tested is test plus ed, etc. And, he's pretty happy at this point. He can match words not only when they're capitalized differently, but also when they appear in different tenses or with different suffixes, etc. Now, the question is, what do we do with these words? So when we had code coverage and documentation coverage, it was quite easy to picture how to represent it on a space. But how do we do this for words? So basically, we need to go from words to numbers if we eventually want to represent a whole email with numbers, with a series of numbers. So what we do is that we look at the context in which each word appears, and we make the assumption that words that appear most often close together are also close semantically. Now, with this assumption, we can then map the words that are in the same context as close together. Let me explain a bit more. So if we take an example, if I notice that the word bug appears very often near the word sad and almost never near the word happy, then I can deduce that basically they belong to the same family of meaning. And we have some very powerful algorithms in NLP that can exploit this information, and they create numerical representation for words. And they're called embeddings. Now, embeddings help us obtain a space that looks a little bit like this, where we can find, in our example, positive words all cornered on the top right, and negative words are all on the bottom left, and all neutral words are in the middle. So this is good. So we have a representation space for all of the words that can appear in any email. But what does the CTO do at this point? So he needs to exploit this mechanism. One moment. Okay. So he uses these things, embeddings, to extract semantic information about those emails, and it allows him to make some simple predictions of whether a developer is happy or unhappy, just like before. So, for example, he can take each of the words that make up an email and take the vector that represents them and make the mathematical mean between them. So if we look at it in our embedding space, so we have lots of individual vectors, and we end up having only one vector that represents the whole sentence, that it's kind of like in the center between all of them. And now we can repeat this for all of my emails. And we end up having something that looks like this, which is very similar, if you remember, to the slide where we had all the little faces of the developers. So each of these emails represents a developer, and it's somewhere in an embedding space. So now we know how to represent each email, which is good. We have some numbers, and we know artificial intelligence loves numbers. And we can label them first, of course, and then we feed them to our NLP model as training data. So the output of this model is that the HR department can predict the happiness score for each new email that comes in, pretty much in the same way that they did before with the regression model that we looked at before. And this looks fantastic at first sight. But if we're honest, this is completely based on how good the mapping for the words is. And it means that it's also only based on semantics. So it's done in a way that is too simple. Because if we try to look at a sentence that is a little bit more complex, not even much more complex, like I really never test my code, and we try to do the mean, once again, between the position of each word, so we reconduce those two here, we see that it seems to have quite positive meaning. And we know that this is absolutely impossible. A developer that never tests their code cannot be happy, really. So it looks like there is a problem and the CTO needs to fix it. So what does he do? He looks up his machine learning notes and decides to add another ML piece to to help his embeddings. And this new piece is called recurrence. Now, our embeddings, so the red piece, didn't really look at the relationship between words, didn't look at the order. It only looked at semantics. So it understood things really in quite a dumb way. Now, recurrence, on the other hand, it gives meaning to the order in which things appear. So basically, when we move from one word to another, it keeps some sort of short-term memory, and it can alter the meaning of a word based on what came before. And especially, it's able to look at words that are present in many different semantic contexts and don't seem to have a specific value of their own. And these are words like very, some, not, etc. And recognize that actually they're not useless. They do have some utility because they react to the semantic value of other words in the same sentence. Oh, sorry, froze again. Let me see. Okay, yes. So he puts together the two pieces and looks at what happens. So the new model starts looking at the tokens in order. So takes them one by one. So first we see the word I for the sentence, I really never test. And I is quite neutral, so nobody says anything. But then we get to the word really. And really has an amplifying meaning. So the recurrence recognizes this and starts kind of repeating to himself, amplify, 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 remember to amplify. And then we move on to the next word. The next word is never, which has a negating effect. So once again, recurrence identifies this and says, okay, amplify, negate, amplify, negate, amplify, negate. And finally, we arrive to the word test, and here our embedding piece sees this and says, oh, I know this, and looks it up, sees that it does have a polarized value, and says, okay, but it means that this sentence so far must be sent by a happy developer. At the same time, yellow piece keeps saying, amplify, negate, amplify, negate. And because we're at the end of our sentence, once we put the two together, we have the embedding that tells us that it's a happy email, and the recurrence that tells us to amplify and negate whatever the embedding said. So in the end, we find out that the developer who sent the email is very not happy, which is good. It's what we wanted. So CTO is super happy. He sends a new model to HR and says, use this for all your future predictions. But we have another problem. We know that chatty developers do exist. They're quite rare, but they exist. We all know some of them. And one day, HR receives a very, very long email in which this developer decides to be oversharing. He talks a lot about his life, not just the professional side. He talks about, his wonderful wife, his children, where he's going on holiday, his friends, etc. And somewhere in there, he also says, "But I never test my code." But overall, he's conveying like enthusiasm about the rest of his life. So, having some problem with slides again. Okay. So this means that when the NLP algorithm that we've prepared processes this, it will make a prediction that the developer is really, really happy. But the CTO looks at this and says, "Oh my God, not again. This is not possible. It failed, because if this developer doesn't test his code, there's absolutely no chance that he's really happy. There must be a mistake." So all this chatting about wives and children and holidays has confused my algorithms. I need to do something about it. So once again, he decides to add a new piece to the puzzle. The new piece is called attention. Attention is a mechanism that gives weight to important things and ignores the things that are less important. So the concept is that the concept of what is important is completely dependent on our objective. So in our case, the attention mechanism will prioritize information related to developers' happiness at work, and it will give less weight to things that belong to different semantic areas. So we introduce this piece and we try them all together. And what happens is that when the developer talks about personal stuff, the attention piece is kind of distracting the other two and says, don't pay attention at all. It prevents them from doing their job. But when we get to something that talks about code quality, which we know is important, it shuts up and forces them to do what they have to do. So they do the usual. So recurrence identifies that he has to negate. And then the embedding piece recognizes when there is a polarizing word like test, and that is happy. And finally, the rest of the sentence is pretty unusual. And finally, when we get back to talking about holidays and friends, attention once again says, no, don't listen. Don't pay attention. When we get to the end, we put together everything that we have. So embedding and recurrence, what they were able to guess in the moments that they were paying attention. And we realized that the developer was definitely not happy, which is the correct conclusion for the CTO. CTO is very, very proud of himself, and he presents a new model to HR, and everybody's happy. And this brings us to the end of this presentation. Now, I guess the meaning, wait, 1 second. Once again, it froze. Okay, yes, the message I want you guys to keep from this, apart from the story, is that all impressive neural networks of NLP really are just very smart combinations of these mechanisms. So we have semantic mechanisms that find meaning in words and subwords. We have recurrent mechanisms that capture the order dimension of sentences, and attention mechanisms that select interesting parts from text, depending on what our objective is. And these are, some of the most relevant mechanisms from NLP. They're not the only ones, but I'll let you guys look up what the rest is. And now, just to conclude, we actually asked a famous NLP model when a developer is happy. GPT-3, probably many of you have heard of it. So I kid you not, we really, really asked this, and we got this answer. When a developer is happy, but when their code works and when someone else has to maintain it. And when a developer is sad. When a developer is sad, when their users are sad. And when other users are sad, when you've broken their trust. And on this poetic note, I want to thank you for paying attention to my silly story. I really hope you enjoyed it and that you learned something from it. Now, at the start of all this, I also told you that I am a developer. I'm not a data scientist. So why is it me presenting all of this to you, considering I work in a company where there are many great data scientists? But the reason, let me introduce the reason to you. His name is Hamza Saya, and he's joining me now on this virtual stage. Hello, Hamza.
Hello, Benny.
Hi. Around 8 months ago, Hamza introduced to Ponicode a new format that he called ML Inspiration. So every week, Hamza holds a 30 minutes presentation about a machine learning topic of his choice for the benefit of the whole team. So developers, data scientists, marketing team, sales, anything. And that's 20 minutes of presentation plus 10 minutes of Q&A. And I am always there. So we actually thought it would be cool for me to try and give back and make a talk inspired by Hamza's presentation and explain kind of the concepts that I learned from him. But machine learning's inspiration is so loved at Ponicode that we thought we'd actually share a little bit more about the format that might inspire some of you to do the same. And there is no better person to do so than Hamza himself. So Hamza, can you tell us how the idea came about and why you decided to start ML Inspiration?
I think we could say it started with a bit of frustration in a sense. The tech team at Ponicode is made up of an equal number of developers and data scientists who have very different backgrounds and expertise. And I noticed the communication between the two was not always easy. Lots of things were being lost, shall we say, in translation. And often I think we suffered from not having the same vocabulary and knowledge on certain specific topics. You know, they say that in a conversation, there is always a distance between what I want to say, what I say, what you hear, and what you understand. And the difference between them can be significant. I figured that we need to reduce this gap in order to work together well. And I know that my machine learning knowledge comes from years of study, so I shouldn't really expect others to understand immediately when I speak about something technical. I watch a lot of videos on YouTube, and I am a big fan of scientific vulgarization. So I figured I'd try to apply it myself to bridge this gap between data scientists and developers at Ponicode.
That's really, really interesting. And how do you prepare for it then?
I'm really passionate about what I do. And because of this, I end up speaking to lots of people about it. And it frustrates me when I want to communicate an idea that I find fascinating. So I do this often, and I know the points where people block. And I reflect on it a lot and try to find analogies and tangible examples that can make the concept more clear. So in reality, the larger part of my preparation is done in this informal context with my friends and people I know.
But okay, that's really, really interesting. So I know that I personally enjoyed all of the machine learning inspiration because I learned a lot of things. But what improvement do you see in the team so far?
I'd say there were three effects I noticed. First, inspiration, which I guess was the main goal of the given the name. I have had people come into me with new ideas inspired by my presentations. Second, communication between devs and data scientists has been more fluid. In many cases, we can use words from the machine learning dictionary without fear of being misinterpreted. And it happened a lot less to waste time debating semantics like before. And finally, I actually think that it has bounced back and inspired us data scientists, because during the Q&A part, developers often make comments and ask questions on our domain, which is code, which in many cases have made us realize new things and think about other approaches.
And what do you think that other teams that might be watching us right now can take from this?
I'd say that whenever there are different expertise that work closely together, especially when topics are technical, miscommunication and misinterpretation are always big risks. So this format of scientific vulgarization can definitely be adapted and would be very beneficial.
Hamza, thank you very much. Guys, I hope this was a bit self-inspiring for at least some of you. If you have any questions, contact us.
Thank you.
Hi everyone, my name is Ash Her. I'm a multimedia artist and creative technologist. I work in augmented reality, and I think AR is one of the most exciting mediums for modern day artists. Before AR even came along, artists have always been interested in breaking down the boundaries between natural and artificial realities, which largely parallels the work being done in AR today. But apart from art, there are so many other use cases for AR, and the principles of what makes a magical AR experience is universal. So whether you're creating an art installation, an app, an interactive birthday card, or a game, I'm here to share with you today how to create those great mobile AR experiences. So at a high level, there are presently two types of mobile augmented reality experiences. You're either augmenting an object or you're augmenting a place. Augmented objects are things like face filters or making a poster, card, or some other 2D screen come to life. Augmented places are things like location-based tours, visualizing furniture in a space, or creating a fictional narrative. Regardless of what you are augmenting, there are 4 elements that you will need to consider in developing these experiences. They include considerations for screen, environment, motion, and illusion. One of the most common challenges for AR projects are the constraints set by the screen. Up until now, our 2D interfaces were primarily used for controlling 2D interactions. Now, a touch screen serves 3 purposes: for your 2D interactions, as a 3D cursor, and as a viewing window for your AR experience. And while it's tempting to call AR an immersive experience, we're still constrained by the limits of our screen. And because the screen is a window to our new world, it's important to maximize the visual display of it. Having too many controls clutters the interface and it distracts from the augmented experience. So keep the screen simple and consider Hicks' law, where the need to make decision increases with the number and complexity of choices. If we want our users to prioritize our experience, it's best to provide a simple and clean interface for the user to easily digest it. Here I'm showing the Adobe Aero interface, which I think does a good job of maximizing AR screen space. Another screen-related consideration is the comfortable-to-reach areas on a device. It's best to place your important controls in these easy-to-reach areas, and lately, more apps are utilizing the bottom of the screen for these important controls. Here are some examples where the primary interaction elements in augmented reality are located in those easy-to-reach areas. The second consideration is that mobile AR is an environmental medium. And because of the environmental variability in which users will experience your AR, it's always good to set expectations for what is required in the experience during onboarding. So when your user is getting started, set expectations on the ideal conditions for using your AR, like defining the amount of space needed or if there should be more than one user participating. This will prime your user for the best AR experience as you intended it. You can also provide contextual guidance if the environment is not good enough. AR Core and AR Kit both have built-in systems for light estimation. So if the environment is too dark or too bright, you can tell the user that they can try to find a better place to use your AR. On the screen here, I'm showing 2 examples where the user is asked to set up the scene correctly for the experience. On the left side of the screen, the user is asked to use the back-facing camera, and on the right side of the screen, the user is being asked to bring in another individual into the experience. These are examples from mobile apps in AR that I think do a good job. Host Separate app is reminding the user to stay alert of their surroundings. The AR Runner app here is asking you to choose the size of your play area. And the Lightspace app here has an effective video tutorial for using their app. And I think these apps do a good job in easing their user into the AR experience. Your environmental situation also influences how users interact within your AR. There are generally 2 categories here. It's either an experience for a private environment or a public one. In a private environment, like at home or at work, you can create longer user sessions with more complex interactions. Here, you'll also find that users are more willing to utilize their whole body for movement within the interactions. Portals are a good example of AR that thrives in private environments. AR portals encourage the user to explore and move around the real world to discover different elements of the AR scene. These generally take a bit more time to get through, especially when you're thorough. On the other hand, there are public environments, like the outdoors, where users are partial to shorter user sessions. This doesn't mean that long sessions should be out of the question, but it's good to have a balance between your 2D and 3D screens so that a user isn't too fatigued. Pokemon Go is a really good example of this. These interactions within our mobile AR window brings me to my next consideration, which is motion. We need to be mindful of how our user will be navigating in our AR experience. In mobile AR, there are 4 main ways in which a user moves within the AR space. They're either seated with their hands fixed, seated with their hands moving, standing, or moving around in a real-world space. But regardless of how the user is positioned, they will need to be holding a device in their hands. And these device types will also vary, creating a new challenge for accessibility. An iPhone 8 would be much easier to hold than an iPhone 12 Pro, which is easier to hold than an iPad. Holding a device for longer periods can be fatiguing, especially after the 30-second mark. Therefore, as a result, many great AR experiences have shorter sessions or built-in periods of downtime during the experience. One more thing to consider is that the context in which your user will be utilizing their AR experience matters. For example, an AR experience inside a grocery store may need to account for a user that would be holding a basket or pushing a cart in addition to holding their device. Another example is that if your experience is at an art gallery, it's likely that the user wouldn't need to hold the device at all. And so these factors would influence your user's ability to navigate within your AR space and how you present motion within the experience. Another good practice for motion in AR is to guide the user through the types and ranges of movements possible for the AR experience. This can be accomplished without sacrificing screen space by utilizing visual, motion, and animation cues. Not only do cues inform the user of what elements are designed to be interacted with, these visual cues also act as an accessibility option for users who would be hard of hearing. The example I'm showing on the screen here is of Squishy Hoops, an AR game where they do a really good job of introducing the different interactive actions that a user can take during their AR experience. So speaking of the different cue types, an example of a visual cue would be like highlighting recommended options or showing text that encourages you to follow a command, or placement guides for the tracking and placement of 3D objects. The examples that I'm showing on the screen here are both of instructional text. So motion cues are more prominent in face filters, where a user would be expected or instructed to move their head or open their mouth to trigger interactions within your AR experience. In the examples that I'm showing here, the user is being asked to turn their heads, which is also a natural movement, especially when it comes to face filters. Lastly, a good example of an animation cue is like the fox that was in Google Maps AR. Here, a fox would walk in front of you and help you navigate where to turn. I don't believe that this is still a feature in Google Maps AR today, but the subtle animations like these highlighted arrows do the job just as well. There are also times when you would choose not to include instructions as to encourage the user to move and discover the experience on their own. More often, this is seen in art installations or AR that is designed to be more experimental. And lastly, let's talk about the most important aspects of augmented reality, the illusion. Regardless of the aesthetic or style that you're going for, AR objects that engage with and reflect their environment are the ones that make AR magical. Incorporating things like shadows, lighting, occlusion, reflection, and collision all support the illusion of your AR. For 3D objects, attention to detail really matters. For models that you want to look real, use physically based rendering texture models, add visual noise to a texture so that it's not just a repeating pattern, and utilize normal maps to achieve a more realistic look. It's also important to note that these objects can get heavy, so it's best to minimize the size of these textures as much as possible so that your scene can load faster. You can reduce the size by using compression tools like Draco or reducing the polygon count of your objects. Furthermore, light and shadow are also critical in creating realism in AR, so be sure to reflect environmental lighting conditions onto your virtual objects, cast object shadows, and add reflections onto surfaces to create that more realistic look. I found that the best place to position light sources is overhead at the 12 o'clock position, and it's also likely to be more congruent with the lighting conditions that of your user, as opposed to directional lighting. Lastly, sound is also a wonderful way to delight in AR by setting the scene, creating a mood, and adding to the illusion. You can also use sound to guide your user around the virtual space or as a tool in confirming interactive elements within your 3D space. As you can see, there are many ways and combinations in creating engaging augmented reality. There's also so much more here on building great AR experiences in regards to shaders, textures, animations, and interactions, but that is a talk for another day. Today, we spoke to considerations for screen, environment, motion, and illusion factors in building your AR experience. And keep in mind, AR is still evolving and there is so much more to be created. So if you're interested in creating an augmented reality, there are a number of great tools out there to help you get started on the right track. I'll speak to several of these development tools first. So first we have AR Core, which is free, and their latest version allows for cloud anchors, motion tracking, environmental understanding, light estimation, which isn't really different from what ARKit also offers. But the ARKit SDK is limited to iOS devices and also offers people occlusion, simultaneous front and back camera use, multiple face tracking, and collaborative sessions as an advantage to AR Core. And then we have Unity, which has a really robust toolkit for AR development called the Unity AR Foundation, which includes core features from ARKit, AR Core, Magic Leap, and HoloLens. And what's unique about the AR Foundation is that they let you take currently unavailable features with you whenever you switch between AR platforms. So if a feature is enabled on one platform but not another, they'll help you transition so that whenever you are switching platforms, you're not rebuilding the AR experience from scratch. And then we have Lens Studio by Snapchat, which is also incredibly robust and also has good documentation to get non-developers started in augmented reality. Another pro with Lens Studio is that you can quickly deploy your AR in Snapchat to its large user base. And lastly, I'll talk about Spark AR, which is Facebook's AR platform. I've been using Spark AR more often as of late, and similar to Lens Studio, Spark AR is also really great because much of the AR infrastructure is already built for you, and it's an easy way to distribute and share your work as it publishes your AR experience to its users on Facebook and Instagram. Next, I'll speak to some of the other tools that are more focused on creating the 3D content within your AR experience. I won't be speaking to all of them in the interest of time, but I'll start here with Sketchfab. And Sketchfab is a really great platform for discovering 3D objects. You can purchase or even find free 3D models to download here and incorporate into your AR experience. There are a ton of really great models here. And here we have Quill and Tilt Brush, which are both VR drawing tools where you can create 3D models, animate them, and then incorporate that into your AR. You can also get some pretty cool workflows here. And lastly here, Blender and Cinema 4D are both incredibly powerful 3D graphics tools for rendering, animation, and modeling. Blender is awesome because it's free and incredibly powerful. I've used it for modeling, sculpting, rigging, and rendering some of the 3D models that I've used in my AR, but both of these tools are really, really incredible. I'll close with this quote here, and I encourage you to go and create an AR. Create those experiences that are worth sharing. Thank you so much for watching. Feel free to keep in touch. I would love to see the things that you make in AR. Hope you enjoy the rest of your conference, and thank you for tuning in. Take care.
Hi, I'm PortraitXO, and I am here today to talk a bit about neurosynthesis. I am an interdisciplinary artist. I started with classical piano training, and my obsession with electronic music production is what led me to my obsession with music gear, music technology, and where I am now working with AI and new media. So I'd like to start off with talking about two really strong emotions that I have found myself experiencing, and also with other musicians when I've talked about new technology. And that is fear and fascination. And what's really interesting is how sometimes when there is a new technological advancement, we have this fascination and curiosity and interest in it. At the same time, sometimes there are feelings of fear that this new technology might replace an old technology, and maybe along with it, replace or get rid of old approaches and jobs. But we have seen throughout history that this isn't always the case. The acoustic piano and synthesizers are both used in music production and live performance, and they've simply proved that there are just two different ways of expressing and creating in a similar but different way. And we could say the same about guitars. Acoustic guitars and electric guitars are similar approaches, but one hasn't replaced and gotten rid of the other. They both still exist. And so I found myself very curious about these similar feelings around AI. What is AI? What does it actually do? And I think most of us, when we think about AI, we have an image in our heads maybe similar to this. AI has this possibility and ability to really prove as a interesting tool for self-reflection, and it can be the most intimate way for humans to understand our own selves, at least through data. And I really wanted to explore a little bit deeper into my own feelings of fear and fascination with AI, and lift the hood and understand what does it mean to even work with data in the first place, and what does it look like, what could it sound like. And what has been really interesting throughout my research was to understand the limitations of the technology. So while I think it's really interesting and important to see how far our human imagination can go and the actual possibilities of these fear-based thoughts and emotions, I think it's also interesting and important to understand the limitations of the technologies. And I have found a lot of creative inspiration in learning the limitations. So last year, I started my artist residency at Factory Berlin, which I finished earlier this year, and I focused on computational creativity and human-machine collaboration. And so here, my project partner, CJ Carr, and I decided to feed 1 hour of my vocals from previous songs into his custom neural network that then produced 10 hours of new audio over 2.5 days. So CJ Carr is also a musician and a data scientist, and he specializes in machine learning with raw audio. And so just to give you some samples of what this journey sounded like and felt like, here is one audio clip from the first day, and this is one of the earlier audio clips. So a lot of distortion, a lot of noise, but creepy sounding. Almost sounds like a ghost in the machine, and you can tell there's like a human voice trying to come out, but not quite. Middle of day one, we started to get some more melodic content. Towards the end of day one, we started getting a bit more clarity and some lyrical content. By day two, we started getting clearer audio with longer phrases. So what's been really interesting about this project was listening to 10 hours of audio like this. First of all, 5 to 10% of it was actually usable with audio clips like this, where there were actual lyrical and melodic content. And while it didn't create full long enough phrases where you could hear a cohesive melody or a lyric, it created a new approach to songwriting that I didn't predict to come out of this. I actually didn't know what would end up, what would the discoveries be at the end of this research project. And what ended up happening was this game of fill in the blank, because AI wasn't smart enough to create these full phrases. And also sometimes the audio that came out, it sounded like words, but not always. And it was a bit of combination of gibberish and full words. And so this fun game of fill in the blank is an approach that we decided to use for Eurovision's first ever AI song contest that they did earlier this year. And we helped Germany win the jury vote, which was really exciting. And they awarded us based on the most creative use of AI. We decided to use as many custom neural networks that DataBots really wanted to push to really find out how far we could go with the creative use of AI. And so here is a little sample of the song. And one approach that we took was feeding his AI model, or DataBot's AI model, with a bunch of songs from 1950s of Eurovision songs. And I decided to co-write in a duet fashion. You can hear the entire track on YouTube and Spotify. It's probably one of the weirdest songs I've ever been part of. It's got like death metal in it and some weird, strange pop EDM. And we got some really interesting reactions and new dialogue and new narratives. And the Eurovision jury team were invited to write about the contest, which was featured in Google's Magenta Team's blog, which you can read more about to find out some deeper insights of some of our approaches. And then a few months ago, I really wanted to dive a little deeper into creating a much more tangible, like a physical experience of this data. And so I collaborated with another interdisciplinary artist named Sibeli Cavalli Bastos, and Instagram's Spark AR platform recently around that same time released this ability to introduce audio into Instagram filters in a new way. So we decided to create this filter where we showcase 3 of the AI audio samples, and you can glitch the visuals and the audio at the same time. You're more than welcome to visit my Instagram page where you can try it out. And I will close this presentation with my one GitHub contribution, which is a nice one I like to talk about because it also ties into how my obsession with creating physical experience all started. And I hope to contribute more exciting projects to GitHub. This was a hackathon that I participated in back in 2018 at USC called Creating Reality. And we won the grand prize and winner of AR and VR for good category. And for the project, we decided to give people an experience using HoloLens, translating colors into sounds the way I experience colors and sounds. So you could like tap different colors with your fingers. And that was a really fun experience to have, because I'm not a coder, I'm not a developer, but I'm very much inspired by code. And time and time again, technology has constantly proved to be so inspiring, because they've helped to create these new ways to express and communicate the way I experience senses. And my very, very last thought about technology and AI is, I hope that tools will become more accessible and AI will become more democratized for creatives to work with them. And I hope to see more creative work, because I do think that it's really important, especially now with AI, that we open ourselves up a bit more and stay curious and remember that technology is simply here to be different methods and different tools to help create, and sometimes not even just for creativity, but even in a much more practical sense. And somehow, in the context of AI, we've somehow lost a little bit of this narrative that AI can serve as very interesting and inspiring ways and methods to creating. So this is how you can reach me on social media, mainly on Instagram and my email address. Thank you, GitHub, so much for your time. I will now switch cameras to go into performance. I am going to perform 3 tracks off of my upcoming AI album, which I've created during my Factory Berlin residency. Thank you again.
Something standing into Better than anything I hear. Something stand here into the pit reactor. The silence between I can't speak, I can't speak. Another this is what it feels like, sitting on a wire. Hey, this is what it feels like, sitting on a
Thank you very much, GitHub. Thank you so much. Enjoy the rest of your program.
Hi, I'm Dr. Elliot Hedman. Using emotional sensors to understand your users. How many of you have asked this question, why are customers leaving our product? Or we could flip that around, how do we make this product better? How do we innovate this? My job is I get hired by people to specifically answer these questions about how do we make better products or what's going wrong with our customers leaving. Now, when I work with these companies that ask this question, a lot of times they have a lot of data. And they're looking at this data and they're trying to figure out what's going wrong. But most of the time, that data is missing a key element because ultimately how we answer that question is not through just pure data, but we need to understand customers' emotions. It's the emotions that help tell the story about what's going on and what needs to be done. To give you an example of this is a classic problem I find is a funnel challenge. Is that we have people coming in, but at this exact step, so many of them are leaving. We can tell you exactly how many and at what time they leave, but they can't tell you why they're leaving. And that's really the question you need to ask is, what is happening here? How do we change this? How do we get more people engaged? That's an emotional question because, maybe the answer is, well, you asked them to make a choice and they didn't know what to do here, so they quit. Or maybe the answer is, they just came in because they wanted to play with your product, but you never gave them a chance to play. Or maybe you've really confused them. They don't understand what's going on and they're quitting at this point in time. All of those stories can explain this data, but our data is really bad at telling that part of it, the emotional part of what customers want. That being said, there are ways you can measure customers' emotions, and that's what I focus on. Extracting the human emotional element from data alone is hard, if not impossible. If all you're looking at is web traffic, you're not going to get the full story. But there are some really cool ways of measuring emotions, and that's why I was invited to this talk. And that's what I want to talk about here, is this sensor that I helped create at the MIT Media Lab for my PhD. This is a skin conductance sensor. It measures how open your skin conductance is. Now, why would that be important? Well, and I know I have a technical audience, so I'm going to get a little more technical than usual here. What we're doing is we're putting electricity here, and it goes all the way through, and then it gets out to the other side. And what we're measuring is the conductance. It's kind of the inverse of resistance. So the more you start sweating, the easier it is for the electricity to go through. So why do I care about sweat? And we're talking about micro levels of sweat. You wouldn't actually be able to see it. But why sweat is important is because it's tied to your sympathetic nervous system. Your sympathetic nervous system is your fight or flight response. When your eyes dilate, your heart starts pumping, your skin conductance also increases. That's when your sympathetic nervous system is activating. It's going up and down all the time. And so with this sensor, we can tell you the exact moment someone is getting excited or they're paying a lot of attention. And what I want to show you in the next 20 minutes is that if you measure your customers' emotions, the number of insights you're going to have into why they're quitting or what you need to do to make a better product is just going to blow out of the roof. It's just a completely different experience once you start measuring emotions. How I'm going to do that is showing you a variety of bizarre case studies. They probably won't directly relate to you, but I hope they're inspiring and wow, there's so much I don't know about people and their emotions that if I just looked, I would find so many other things. So let's get going with some examples. The first example I'm going to show is with the New World Symphony. The New World Symphony holds this amazing classical concerts. But the problem with classical concerts is they're losing about 30% of their audience every year, and new people are not coming in. So my job was to figure out how do we make it so that more people come to the classical concert. And I want to show you a little bit of data from what we got from this. By data, I mean the emotional data. Before I show you the first graph, I need to explain a little bit about how to measure skin conductance. You're going to see a ton of these graphs. We have way too many graphs in this presentation, but they're really fun. So as you can see, these little white spikes, those are moments of skin conductance increasing. That's when a person's getting excited, they're getting more engaged, their skin conductance is increasing, their heart's starting to beat faster. And these moments where we don't see those spikes, those are moments when they're getting calm, but probably more likely bored, they're struggling to pay attention. So when you see these spikes, these are moments of high engagement. And when you see these dips, those are moments when the person's checking out. So let's look at some spikes here. This is an expert concert goer. He loves going to the New World Symphony, and this is him listening to the Firebird. You can see with all these spikes, he's getting engaged, he's loving the music, he reported it was a really great experience. Now in the next one, I need you to pay close attention to this one, because in the next one I'm going to show you a similar experience, but in this one, the concert goer had never gone to a classical concert before. Let's look at his skin conductance. Okay, just in case you missed it, this is the person who's never been to a concert, and this is a person who's gone to a ton of concerts before. We saw this type of result all the time, that a person who's never been to a classical concert, they're not reacting to the music. It's really hard for them to get emotionally engaged. But that doesn't mean that, no one can react to the music. It just means that they actually react to very different things if it's the first time they went to the concert. So let's take a look at another person's first time going to the concert, but I'm going to zoom out to the entire concert so you can see a little bit about what does excite them. So the yellow part here at the beginning, that's them listening to a classical concert. But then a host comes up and an MC starts talking. And every time the MC starts talking, we see that person re-engaging, staying awake, staying alert when they're being talked to. And this talk doesn't actually last for very long. As soon as after a minute, the host itself actually starts becoming boring too. But what's happening here is a transition. When we move from one item to another item, it gets us re-excited. It gets us re-alerted because there's novel information. So with this point, I actually advise the New World Symphony that you need to make your classical music only about 1 minute to 2 minutes long because it's really hard to pay attention, and then put different things in between them to keep us awake, to keep us alert so that we have new stimuli. Now, on the second part of this person's concert, we can actually see that she does react to some music. This is the quietest part of Romeo and Juliet, and this is the main theme of Romeo and Juliet. Now, I'm not going to sing it for you. Sometimes I try, but I'm a little rusty at this point. But you have heard the main theme of Romeo and Juliet again. It's the classical love theme. You hear it all the time, like in cartoon shows and things like that. When this person heard the concert, she recognized that theme as well. She got very excited when she heard that very emotional part that she knew. It ends up that we have emotional reactions to things that we are familiar with. And when we're familiar, we can anticipate it and we can actually play along with the music. So, with that being said, what I recommended to the New World Symphony there is, why don't we start giving them music that they're familiar with instead of these kind of esoteric music that only experts would appreciate as much. So maybe we should be playing more Red Hot Chili Peppers instead of Beethoven. Okay, so I'm imagining a lot of you guys in the audience do not make classical concerts. So I'm going to show you some things that might be more relevant to you in web design and e-commerce as well. So this, I was working with a big box company who was working on how to better sell iPads and laptops. This is the emotional experience of someone as they're browsing by themselves. Those little spikes right there, that's them getting excited. They're figuring it out. They're engaging with the product. And then an employee comes in. And when the employee comes in, we see a huge dip. That employee actually ruined the shopping experience for the shopper. That the employee started talking about trying to upsell them, trying to get them to buy a cell phone. But they removed the shopper from being able to play an experience. You're going to hear the word play a lot. I find it usually describes the best experience you could have for your user in whatever experience. So what I did is I showed this to my client, and we had some conversations about, we need to reshape what a shopping experience is. And an employee is not there to help push a sell. An employee is there to open up the experience and to create an even better playing experience. But when the employee did this one, they actually literally took the iPad out of the customer's hand to show them things. And that's not what we want to be doing. Okay, speaking of play, this is my favorite example of creating play experiences. I was hired to solve this really fun problem of how do we sell more vacuum cleaners. Not the regular vacuum cleaners. These are the big vacuum cleaners that you put into the garage. I watched a bunch of people buying vacuums, and while a lot of them didn't have the best experiences, I noticed that there was a constant theme of when they started using the vacuum cleaner, they would get excited. So if they're opening the lid, if they're turning on the vacuum cleaner, if they're turning on a weaker vacuum cleaner, these are moments when the customers were getting excited. And so we sat down and we kind of brainstormed, well, what would it take to even make that more fun? If people like playing with the vacuums, how can we make playing a more central piece of our experience? And so we actually created in our prototype a water fountain. You could actually plug in the vacuum cleaner to the water fountain and it'll suck up different amount of water depending on how strong it was. When people were trying out this vacuum cleaner prototype, they actually said it was the best shopping experience they ever had in the store. Now, we then measured people's emotional experiences as they were trying out the water fountain. And to no one's surprise, that water fountain, seeing it go up and down, was an incredibly engaging piece to the buying experience. Now, this might all sound really fluffy so far. It's like, oh, that's cute. You know, people are having a better emotional experience. But this has real live consequences. When we implemented this, we actually created a water fountain and put it into different stores. Now, we didn't really check with facilities, and we weren't allowed to make water fountains, so we had a tennis ball water fountain instead when we tested it. But when we tested out this water fountain idea that was showing emotional engagement, we got 9% increased sales in vacuum cleaners, just 9% more just by having people more engaged. So the emotional reactions people have has huge consequences on your product if you can design it correctly. And now for my last one, example, I want to show you a story that's near and dear to my heart. So about half of the work I do is with adults, but the other half I work with is kids. Kids' emotional experiences are seldomly measured, and I find it very interesting how much kids need a different type of experience that we're not delivering. So I'm going to show an example of that. First, I want to show a video of a kid as she's learning to do double-digit addition. Now, there's going to be a lot of things on this screen, so I'm going to explain. She's using the screen over here. This little red and white dot up here at the top, that's eye tracking glasses. So we can see exactly what she's looking at when she gets engaged. On the side here is her skin conductance. You're going to see orange spikes when they're getting excited. And this is where we are right now. I will just give you a spoiler right now. Something's going to happen where she's going to get a huge spike. I want you to try to figure out what's going on. And I'm going to unplug my mic and hope this works.
That's not quite right. Look at the picture. What is 26 plus 7? That's right. 26 plus 7 is 33.
That spike right there is bigger than you'll ever see in a person playing video games, and a person buying things, and a person playing with Lego sets. That spike right there is the biggest spike I've ever seen in any of my research before. It all came about when a kindergarten girl solved 26 plus 7, the first time she's ever done double-digit addition, and she got it right. And I want to talk a little bit more about how this emotional data helped inspire us to build new products and what the consequences of that were. Oh no, I pushed the wrong button. Okay. So just to kind of get a zoom out, hey, remember I told you I was going to show that graph again? Here it is. This is when she's asked what is 26 plus 7. Asking people questions consistently creates spikes. And then she answers it wrong. But answering it wrong does not disengage you. It actually re-engages you. You're like, oh man, there's something I don't know. I got to pay more attention. And then she answers it correct, and we get the biggest spike we've ever seen. Now, I've done about 5 years of research on what it takes to create good educational software. And I want to show a little bit more about what we were finding here. Consistently, we found when kids were reading, they were getting really bored. It didn't matter what the book was. It's just reading really disengages kids in our iPad generation. But while reading was disengaging them, whenever they got to a question, they got excited, just like in that graph I showed you before. And we saw this pattern over and over again, is that the questions are the central piece of educational software for kids. But that's not how we build educational software. Most of the questions are put at the end, and they're kind of just there to confirm the kids did it, where the reading's supposed to be the central part. Well, we flip that on its head, and I want to show you what happens. I work at the Boys and Girls Club. With COVID right now, I actually work there every single day as a literary specialist. And I work with kids to figure out what would it take to make it so reading's not boring for you. That's my job. And I want to show you what we did. So the next graph I'm going to show you, we took a 3rd grade English language learner, and we had him read The Adventures of Dr. Dolittle. And I'm going to show you the graph of what that looks like. You can see we started out with some spikes as I introduced the book. But at 7 minutes in, he and Dr. Dolittle, they're not the best of friends. I actually went into the research booth, and there was a big pile of drool on the page he ended on. Now, this is the experience for so many 3rd graders out there right now, especially when they're at home and they don't even have a community to read with. Now, that doesn't mean that now this kid, he's being told he's lazy, that he's stupid, that he's horrible at reading. He's getting these messages in him, but I don't actually think that's the case. The case is more that he didn't have a good emotional stimuli with the reading. So that same day we gave him this test, we showed him what we've been developing, which is called Wonder Stories. And in Wonder Stories, we had the kid be able to answer questions. Right now, it's like you can answer 7 questions in about a 5-minute story. So there's constantly critical thinking, and there's constant interactivity. It's not just a passive story. And I want you to see what happens when he read Wonder Stories. That's the same kid, but now he has all these spikes because he's cognitively engaged and he's participating in the reading. And at the end of it, he gave me his favorite compliment, my favorite compliment, which was, wow, that was almost as fun as math. But as you can see, when we understand people's emotional experiences and design for them, we can do incredibly different things, but we just have to really look in and understand what's going on. Now, I kind of had another theme here, but I didn't want to spoil it at the beginning, which is not only should you measure emotions, but how we present emotions can massively change your attitude to things. I did a test with Lego where I told them that they need to include parents more with their building instructions, and I got 18% buy-in when I just told the story of a kid who really needed help. I showed a video of a kid with that skin conductance, much like I showed a video to you guys. We got 75% buy-in. Now this is interesting. I told the same story, but in one I showed the data, the emotional data, and the other I just told the story. It ends up being the case that we don't trust emotional stories very much. We want that data, we want the numbers. But when you just give me an emotion without the numbers, it's really hard for me to believe it because I'll come up with my own story. And that kind of comes into the first insight I wanted to share. Without emotional data, stakeholders use their gut to make decisions. We kind of decide, did I enjoy it, did I not enjoy it? That doesn't work very well if you're doing it for kids or you're doing it for a customer who might be thinking a little bit differently than the CEO. The second insight I want to share with you is you will never design the right emotional experience the first time. When we built those vacuum cleaners, it wasn't correct. I'm still working on Wonder Stories. Sometimes it works, but sometimes it doesn't. We have to keep changing things over and over again to figure out what emotional experience works. Customers are good at telling us when it doesn't work, but they're not necessarily good at telling us how to fix it. And so you have to keep iterating to build those really good emotional experiences. Number 3, businesses are obsessed with happiness. I'm sure you guys have some happiness index about what you want your customers to feel like. But I actually suggest looking at different emotions because happiness, as you can tell, I never put that in there. You should look at confidence, attention, understanding, and play. Number 4, if a test user does not actually need your product, you will not measure accurate emotions. Most user tests are with people who don't care about your product and they're just clicking through, and surprise, they're not having an emotional reaction. Number 5, measuring emotions add the much needed human element to your data. At the end of the day, this is what I want you to take away. You should look into ways of measuring the emotions of your customers. There's many ways of doing it, and you're going to be incredibly excited about how I'll help you innovate. We've ran out of time. I'd love to keep this conversation going. I'm not able to connect via this way, so please email me at hedman@media.mit.edu. You can check out more examples and a whole bunch of literature at buildempathy.com. Thank you.
Well, it's good to see you back here at the end of day 3 of GitHub Universe. It's been a jam-packed 3 days, and today I'll highlight some of my favorite talks and performances from the week. Then we'll have some fun with some of the best and funniest moments of the last 3 days together. It's time to celebrate the end of GitHub Universe 2020 on today's GitHub Universe Highlight Show. Hello, everybody, and welcome to the GitHub Universe Highlight Show. I'll be your host, Kyle Daigle, and hopefully you already knew that. It's the end of day 3, and I get the distinct pleasure of sending you off until we see you at GitHub Satellite early next year. All right, let's dive into today, and then we can get to the after party. All right, in today's feature session, principal engineer from Google and, of course, from Kubernetes fame, Kelsey Hightower joined us to share a bit about his journey to becoming the person you know him now in the open source community.
Started for me around the age of 15. And there's a long trajectory between those humble beginnings to the person you speak in front of you today or commit to your open source or your favorite open source project.
Now, Kelsey's talk was about Kubernetes, GitOps, and the humans that glue it all together. And he started by sharing a great story about marathon runners and how we can learn from how they can work together in order for us to succeed.
If you want to understand GitOps, you got to understand the why. Why are you using it? What's important about it? What's the Peloton formation you're trying to build around you? And is it designed to help you go faster? Or are you just doing stuff because people said it on Twitter?
I love that quote. And in some ways, this technology isn't as new, which Kelsey explained. He talks about how behind every process improvement change that we make, or software products that we write, it's really the humans that make it all work.
It's the humans that should be front and center. Today, we'll be talking about Kubernetes and GitOps, and the thing that kind of depresses me a little is that we tend to put all of these tools before the humans that use them. When you think about Git, it's one of the world's best collaboration tools for writing software, and GitHub is where we all meet and collaborate. But it's the people that make all of this work.
During his talk, Kelsey shared one of the key tips that you can follow to make GitHubs work more easily between your Kubernetes setup and by using GitHub Actions. It's pretty simple. Keep your configuration repo separate and lean on GitHub Actions. Here, take a look.
Keep your config repo separate. So what does that look like in the GitHub world? Well, you probably know what this looks like. If I click over here to my GitHub tab, I just have another repository where I'm storing all of my configs. And here I can have my same Git flow. I can do pull requests, I can review them, and all of my configs are just sitting here underneath this directory called Kubernetes. I can have other deployment targets. Maybe you're using a serverless platform like Cloud Run. And in that case, you may have another directory of declarative configs that you put there. But the goal is these are just all data artifacts that can be consumed by some other system that can actually take your declarative thing and make it work.
I'm going to be honest, this was really a talk that you need to watch end to end. Kelsey did an amazing job of telling a story here, and you're really only getting a tiny taste in the clips that we picked for you. I highly recommend that you head on over to githubuniverse.com tomorrow and watch the entire thing. The hosts and I have been reading all of your tweets, discussion posts, and it's been so much fun interacting with you during GitHub Universe this year. I'm really going to miss our time together. Let's dive in. Lisa has a message for all of those YAML haters out there. Deal with it. Kelsey's apparent love for YAML came through loud and clear. Me, I'm still on the fence, but I'll deal with it, okay? Now, check out this beautiful illustration by Carlo. You can actually sponsor him on GitHub Sponsors right now. I'll tweet out his handle after this to make it a little bit easier. It covers all the highlights and announcements in a beautiful visual format from the Day One keynote. Really excellent work, Carlo. And finally, we have this amazing image from the US stream today. It was too good not to share. Our US enterprise hosts, Martin and Dana, needed to kick it into business overdrive. And not only did both people wear suits, but Martin was sporting some very classy yellow hair to match Dana. Never change, you two. Thanks again to everyone for sending in your tweets and engaging with us in GitHub discussions. It was so much fun chatting with you. Now, let's move on to the rest of this jam-packed day 3 by talking about our talks. Let's kick off our review of today's sessions by looking at Project Scara. OpenJDK is an enormous open source project that recently made its migration over to GitHub. Along the way, the team learned some of the best ways to ensure that maintainers focus their code review only on the areas that they know best.
We implemented automatic labeling of pull requests with the help of a GitHub application. This means that, for example, let's say you make a pull request and you change one of the make files used for building OpenJDK. Our program will then automatically look at the files in the pull request that you changed, realize you only changed the make files, and then automatically apply the build label.
If you're considering migrating your large project to GitHub, whether that's an open source project or otherwise, there were some great hard-earned tips in that talk. Be sure to check out the replay. Changing gears a bit, as part of the open source community, we tend to focus on the coding, the building of the software on each of the projects. During a panel on maintaining boundaries, balance, and funding in open source, Wes McKinney shared how important non-code contributions can be.
One of the things that I spend the most time doing as a contributor and a maintainer is gardening the issue tracker, so organizing the reports that come in, getting more information from the issue reporters, closing out duplicates, connecting issues together, setting their metadata. Because ultimately, a project that is well organized and where we have as much information as possible about the bug reports or the feature requests that come in is going to make it that much easier for people to jump in and make contributions.
You can find areas to jump into open source right now and chip in with issue assistance by checking out GitHub Explore, or during the holiday season, projects like 24 pull requests, where you can find additional opportunities to chip in. It's been a huge year here at GitHub, and even with all of this going on, Nicole Forsgren gave a talk on the state of the Octaverse, and it's really worth checking out. Here's a quick recap of the talk from Nicole herself.
Here's our TLDR. We talked about juggling work and play, how automation makes things better, working better together, and securing our systems.
There you go. You're all set. If you want to read the full reports, go check them out at octaverse.github.com and check out the whole talk tomorrow, githubuniverse.com. Yesterday, we got a sneak peek from Neha about today's talk on how to customize GitHub discussions for your developer community. Here she is talking about how some of her favorite organizations are using GitHub discussions.
So here's an example here where Snowpack has used a pin discussion as their change log. And so it's kind of pinned at the top. You can see that Fred's got some spot on GIFs here. And what I love is that each comment is a new version and it details, and it allows people to easily reply with thoughts or words of thank or encouragement.
Check out the rest of Neha's favorite GitHub discussion boards in the recording of her talk, githubuniverse.com. And finally, has your mono repo evolved past the point that you can handle it? Derek from the GitHub team has a few ideas for you if this sounds familiar.
It's as your repository evolves that it grows and continues growing at a faster and faster rate as your team grows.
Go catch them all, mono repo tips that is, by watching all of Derek's talk. And that's a wrap on the over 80 sessions from GitHub Universe 2020. And a huge shout out to the University channel and the Play channel, who had amazing content as well that maybe you've missed out on, but are definitely worth a look. A huge thank you to all the speakers, performers, and visual artists from those channels. You really made GitHub Universe a little bit more special. If I intrigued you with any of the highlights, you can go and rewatch all the sessions tomorrow. GitHubUniverse.com, go and take a look. All right, we are in the final countdown of GitHub Universe this year, and now I'm in control, so I want to have a little bit of fun. We've spent so much time with each other. I really think we've gotten to know each other, and I mean, the sign of a good friendship is being able to poke fun at each other, right? Well, the team was excited to share announcements in the keynotes. Well, it didn't always come out in a single take. I decided to beg a few people in the production team and got these bloopers of the day one keynote for you. Check this out.
With GitHub sponsors, you can fund the open source projects. I'm sorry. It's too funny. It splashed on me.
Oh no, I got the wrong word. Manually merging a pull request is nice and all, but how about we let the robots do the work here? What? Okay.
Yes. The key to a crispy pizza is the GitHub Definitely a blowtorch, available today for $9.99 with your GitHub Pro subscription.
This page is looking great.
Professional open source developers. Take it for real. Yeah.
And your line is.
I need to answer it, yeah. Okay, I'm ready. Let's do it. Manually merging a pull request is nice and all, but how about we let the robots do the work here?
And we even have CodeQL automatically selling security vulnerabilities.
Nat, are you okay? Nat!
That's great.
Well, it's been a very busy 3 days with over 50 talks, hundreds of questions being answered in our GitHub discussions board, and you were shepherded through the entire experience by a few stalwart guides during the APAC rebroadcast. These folks have been with you as the local hosts of the developer and enterprise tracks, and I thought it'd only be fair if they were here with me to celebrate the final moments of GitHub Universe 2020. So let's bring back Karan and Mish from the developer channel and the alliterative Daniel and Divya from the enterprise track. Hello, everybody.
Hey guys!
Hello!
Everyone.
Thank you so much for joining me. We're so excited. I'm excited to put the final touches on GitHub Universe 2020 with you. So listen, I calculated it out, and all of you have been on camera for over 15 hours in total, and you've listened to so many talks and questions. Divya, I wanted to start with you. What was your favorite moment from this GitHub Universe?
You know, Kyle, this is my first year at GitHub, and watching Universe so close, it's difficult. Like, everything was so special for me. But if I have to pick favorites, I would say I would pick Codespaces. I love, and in my opinion, I think it's going to be a game changer. It would revitalize like the whole inner developer loop experience for everyone. And being close to students, I feel, again, in these changing times, remote learning, no labs, low-end devices, it's going to be a game changer. I also want to add like the Play channel. I'm not a very music person, but it got introduced like a new genre and a new way of coding and fun possibilities for me. Yeah, so it was so awesome.
I completely agree about the Play channel. It's fun watching all the hosts and guests moving their heads in between the sessions when I can see everyone backstage. Mish, I wanted to chat with you. First of all, your setup looks amazing. And I think a lot of people took notice. I loved your tweet earlier last week sharing your setup. I'm curious for you, do you have a favorite moment from GitHub Universe?
Oh, so many favorite moments, but you called one out already. You know, I love my Twitter. I love my community. So the things I really loved about Universe, there was a talk on our channel about building your community on GitHub, which just like touches my heart so much. I absolutely loved it. And then from the broader community, again, the hashtag GitHub Universe was just going off. I just love the way everyone was sending in all their photos, their favorite moments, showing us how they experience GitHub Universe in this virtual era. It's so exciting, and it makes me feel like, I mean, it's not the same as being there in person, but it makes me feel like I'm able to experience it with everyone else. And yeah, that's just definitely my favorite part of this whole thing.
And Karan, you were with Mish. I hear you used to do a bit of improv, and I imagine that came in handy while hosting GitHub Universe. So tell me, what were some of your favorite moments from the week?
Absolutely, Kyle. I think it's really difficult to pick a favorite moment because it's been such an amazing GitHub Universe this time, hosting this with the amazing Mish out here. But one thing that I really loved about GitHub Universe this time is how we are able to engage with the APAC community in their own time zone, talk to them, see what's happening, and hear to them on Twitter, discussions, and everywhere else. So that is one of my favorite part of how we are able to come together globally, live, and then tune into GitHub Universe this time. Absolutely stoked at all of the sessions and the community engaging with us so much.
Daniel, I can't help but notice, and I think the internet noticed too, that you seem to be a little bit of a Star Wars fan. So first, I'm curious what your favorite Star Wars movie is.
Oh boy. Okie dokie. This could actually get me hated on the internet. That's kind of okay. Of course, I love Empire Strikes Back. Everybody does. But I'm going to give a shout out to The Last Jedi. Rian Johnson, dude, you're the man.
Thanks for being a good sport. And then I'm curious what you think the 56 million developers at home will be most excited about from this big week of announcements and just, GitHub Universe in general.
Well, it depends whether or not you want to talk about on camera or off camera, because off camera, I actually just finished my 7,500 piece Lego Millennium Falcon. But on camera, I would say code spaces, absolutely awesome. Dark mode, everybody wants dark mode, right? And to have it there is fantastic. I know personally from my customers that I deal with on a day-to-day basis, Actions packages, GitHub Enterprise Server 3.0, it's going to win. It's awesome.
Awesome. Thank you so much.
Forgot one thing.
Yeah, go ahead.
One thing. My partner, Divya, she's that side. There she is. No, that side. There we go. Working with Divya was awesome. Thank you, Divya.
A high five there, Daryl.
You too, Karan. I love you too. High fives, oh God.
I was going to say, it's so much fun watching the 4 group here, especially the APAC rebroadcast. It's been fun watching you and your work, the hijinks. I know hosting is not an easy task, and you all had so much fun and really, looked like you were friends throughout the entire process, which is great. So now we're at the end. I think it's time. Does everyone have a glass? We're going to do a toast. Raise your water, your juice. I have champagne. So let's toast this GitHub Universe and all the amazing work that the Hubbers from around the world did to make this possible. Hurry, Mish, hurry.
Hurry, Mish. This is a heavy
mug. I'm popping the bottle now. Can I pop the bottle right on stream?
Yeah, let's do it. Go ahead. Just don't break anything. You've got a lot of expensive stuff there behind you.
Being popped. My housemate's going to hate me right now because he loves the sound of this and he's not here to experience this. When he misses out, you all get it instead. All right, here we go.
Let's see it.
Ready? Here's that satisfying sound. Yeah!
All right, everyone, let's toast to the amazing community of developers from around the world. Without all of you, we wouldn't be here. And listen, I only get to do this once, so I want to cheers with a bang. Cheers!
Oh, yeah.
Thank you so much, Divya, Daniel, Mish, Karan, everyone. Please enjoy your well-deserved time off. Thank you, everybody. And thank you.
Bye-bye.
Thank you, our community. Oh, it's still coming down. Holy moly. For
You're going to be
all your
cleaning that
hard
up
work.
forever.
I'm going to be vacuuming up this for days. Thanks again to the amazing APAC hosts. Thank you to all of you for all of your hard work, all of your work making fixes, answering pages from your apps on Saturday. We build GitHub for all of you, and I can't wait to see what you do with this, with what we built this year. I wish you all the very best for the rest of the year, and here's to a really great 2021. I'll see you next time.